Hi friends, I'm Maruti Konduri, co-founder of Cracku and an alumnus of IIT Bombay Computer Science. In this video, I'll be solving 50 plus carefully selected JEE Quadratic Equations PYQs that cover the important concepts and patterns frequently tested in the examination. Before watching the solutions, I would encourage you to pause the video, attempt each question yourself, and then compare your approach with the detailed solution. This will help you understand not just the answer, but the right way to approach these kind of problems. You can download the PDF containing all the questions along with video solutions from the link provided in the description. This is part of our JEE Maths PYQ series where we will cover all the major topics required for JEE preparation. If you find this approach useful, you can also explore our JEE Mains Maths course, which I have designed along with Radhakrishna Sir, who brings over 15 years of teaching experience from the leading coaching institutes. This course link is available in the description. So let's get started with quadratic equations. In this question, we are required to calculate the sum of the squares of the real solutions of the equation. Log of the base is x plus 1 and the argument is 2x square plus 5x plus 3 is equal to 4 minus log of the argument is x square plus 2x plus 1 and the base is 2x plus 3. If you are looking at the argument of the left hand side, 2x square plus 5x plus 3. This can be factorized to equal 2x square plus 2x plus 3x plus 3. This is 2x plus 3 into x plus 1. So if you're looking at the equation now, we have log of the base is x plus 1 and the argument is x plus 1 into 2x plus 3. This is equal to 4 minus log of the base is 2x plus 3 and the argument is x square plus 2x plus 1, which is x plus 1 whole square. So the left hand side will be log of the base is x plus 1 and this is x plus 1 into 2x plus 3. If we split it, the first term will be log x plus 1 to the base x plus 1, which is 1, plus log of 2x plus 3 to the base x plus 1. And the right hand side is 4 minus 2 times log of x plus 1 to the base 2x plus 3. If you assume that log of 2x plus 3 to the base x plus 1 is equal to t, if you are interchanging the base in the argument, the logarithm will become the reciprocal of its original. That is, log of x plus 1 to the base 2x plus 3 will be equal to 1 by t. So this will equal 1 plus t is equal to 4 minus 2 by t, or t is equal to 3 minus 2 by t. If you multiply the entire equation with t, we are going to get t square minus 3t plus 2 is equal to 0. This is t minus 1 into t minus 2 is equal to 0. So either t is equal to 1 or t is equal to 2. But what is t? T is log of 2x plus 3 to the base x plus 1. So if log of 2x plus 3 to the base x plus 1 is equal to 1, or the second option is log of 2x plus 3 to the base x plus 1 is equal to 2. These are the two possibilities. In the first case, we are going to get 2x plus 3 is equal to x plus 1, or the value of x is equal to minus 2. In the second case, we are going to get 2x plus 3 is equal to x plus 1 whole square, or 2x plus 3 is equal to x square plus 2x plus 1. You can cancel this 2. X square is equal to 2. So either x is equal to square root of 2 or x is equal to minus square root of 2. Now remember that we want the logarithm to be defined. The base of the logarithms over here is x plus 1. So we want x plus 1 to be greater than 0. Only then will the logarithm be defined. So if x is minus 2, x plus 1 will be minus 1, which is not possible. If x is minus root 2, x plus 1 will be negative, so this also is not possible. The only solution is x is equal to root 2. And what are we required to calculate? We are required to calculate the sum of the squares of all the real solutions. There is only one solution which is equal to root 2, and the sum of the squares therefore will be equal to 2. In this question, we are asked to calculate the sum of all the roots of the equation. Modulus of x square minus 8x plus 15 minus 2x plus 7 is equal to 0. Let us look at the expression within the modulus. That is x square minus 8x plus 15. We can factorize this as x square minus 3x minus 5x plus 15. This is x minus 3 into x minus 5. Now, when is this positive and when is this negative? The two inflection points for x minus 3 into x minus 5 is when x is 3 and 5. If x is less than 3 or x is greater than 5, that is, if x is not lying between the inflection points of 3 and 5, this expression x minus 3 into x minus 5 is positive. If x lies between 3 and 5, then the expression is less than or equal to 0. Using this, we will divide this into two cases. In the first case, x lies between 3 and 5. In the second case, x is either less than 3 or x is greater than 5. In the first case, when x is lying between 3 and 5, x minus 3 into x minus 5 is negative. Therefore, modulus of x square minus 8x plus 15 is equal to minus x square plus 8x minus 15. Therefore, the expression that we have, which is this modulus minus 2x plus 7, becomes equal to minus x square plus 8x minus 15 minus 2x plus 7 is equal to 0. This is the equation. If you are simplifying it, you are going to get minus x square plus 6x minus 8 is equal to 0, or x square minus 6x plus 8 is equal to 0. We can factorize this to equal x minus 4 into x minus 2 is equal to 0. So either x is equal to 4 or x is equal to 2. Again, in this interval, we want x to lie between 3 and 5. So x is equal to 4 is a valid root. X is equal to 2 is not a valid root. So the only root in this particular interval is x is equal to 4. In the second interval, where x is less than 3 or x is greater than 5, x minus 3 into x minus 5 is positive. Therefore, modulus of x square minus 8x plus 15 is equal to x square minus 8x plus 15. Therefore, the given equation becomes equal to x square minus 8x plus 15 minus 2x plus 7 is equal to 0. This is x square minus 10x plus 22 is equal to 0. Or the value of x is equal to 10 plus or minus square root of b square, which is 100, minus 4ac, which is minus 88, divided by 2. This is 5 plus or minus, or this is 10 plus or minus square root of 12 divided by 2. Square root of 12 is 2 square root of 3. Therefore, this is either 5 plus square root of 3 or 5 minus square root of 3. What is the approximate value of square root of 3? Square root of 3 is approximately 1.7. So 5 plus square root of 3 is approximately 6.7. And 5 minus square root of 3 is approximately 3.3. Now 5 minus square root of 3 lies between 3 and 5. In this case, we don't want the value of x to lie between 3 and 5. So this is not a valid root. 5 plus root 3 is greater than 5, it is approximately 6.7. So this is a valid root. So the given equation has two roots. This is one root and this is another root. And the sum of both of the roots is 9 plus square root of 3. So the answer for this particular question is option D. In this question, we are asked to calculate the sum of all the real values of x satisfying 2 to the power x minus 1 into x square plus 5x minus 50 is equal to 1. So if 2 to the power something is equal to 1, the exponent has to be equal to 0, because we know that 2 to the power 0 is equal to 1. This would imply that x minus 1 into x square plus 5x minus 50, this has to equal 0. If you're factorizing x square plus 5x minus 50, this is x square plus 10x minus 5x minus 50. This is simply equal to x plus 10 into x minus 5, and of course we have the starting x minus 1. This is equal to 0. Therefore, there are three roots for x. Either x is equal to 1, or x is equal to minus 10, or x is equal to 5. And the sum of all of these roots is 1 plus 5 minus 10, which is equal to minus 4. So the answer for this particular question is option C. In this question, we are told that p of x is a quadratic polynomial such that p of 0 is equal to 1, and p of x leaves a remainder of 4 when divided by x minus 1, and it leaves a remainder of 6 when divided by x plus 1. Let us assume that the polynomial p of x is equal to ax square plus bx plus c. Now p of 0 is equal to 1. So if you substitute the value of x to be equal to 0, we are going to get 1. So p of 0 would imply 0 plus 0 plus c, or c is equal to 1. So p of x is ax square plus bx plus 1. Now if p of x is leaving a remainder of 4 when divided by x minus 1, what does this imply? When you're dividing with x minus 1, you have to essentially substitute the value of x to be equal to 1. And if you substitute the value of x to be equal to 1, you are going to get the remainder. That is, p of 1 is equal to 4. That is what is mentioned when you are saying that the remainder is 4 when divided by x minus 1. And the remainder is 6 when divided by x plus 1. When is x plus 1 equal to 0? X plus 1 is equal to 0 when x is equal to minus 1. Therefore, if the remainder is 6 when divided by x plus 1, it would imply that p of minus 1 is equal to 6. We can substitute p of 1 is equal to 4. So this would imply that a plus b plus 1 is equal to 4. I'm just substituting the value of x to be equal to 1, or a plus b is equal to 3. For x is equal to minus 1, p of minus 1 is 6. So a minus b plus 1 is equal to 6, or a minus b is equal to 5. So we have this equation and this equation. If I subtract one equation from the other, I'm going to get 2b is equal to minus 2, or the value of b is minus 1, and the value of a is equal to 4. So the value of p of x will be 4x square minus x plus 1. If you're looking at the options, we have to essentially calculate p of 2 and p of minus 2. If you substitute the value of x to be equal to 2, p of 2 is 4 into 2 square minus 2 plus 1, which is equal to 15. And p of minus 2 is 4 into minus 2 whole square minus of minus 2 plus 1. This is 16 plus 2 plus 1, which is equal to 19. If you're looking at the options, p of minus 2 is equal to 19 is option A. So this will be the correct answer. In this question, we are told that p, q and r are real numbers such that the roots of the equation 1 by x plus p plus 1 by x plus q is equal to 1 by r are equal in magnitude but opposite in signs. Then the sum of the squares of these roots is equal to what? That is what we are required to calculate. If the roots are equal in sign, equal in magnitude but opposite in sign, let us assume that the two roots are alpha and minus alpha. So what does the quadratic equation look like? The quadratic equation will be x square minus alpha square is equal to 0. The sum of the roots is equal to 0, so there will be no coefficient of x in the given quadratic equation. If you are looking at what we are required to calculate, we are required to calculate the sum of the squares of these roots. What is the square of alpha? It is alpha square. What is the square of minus alpha? That also is alpha square. So we are required to calculate what is 2 alpha square. If you are simplifying the quadratic equation, 1 by x plus p plus 1 by x plus q is equal to 1 by r. You can simplify this. This is 2x plus p plus q divided by x plus p into x plus q is equal to 1 by r. Or if you cross multiplying it, 2xr plus pr plus qr is equal to x square plus px plus qx plus pq. Or this is x square plus x into p plus q minus 2r plus pq minus pr minus qr is equal to 0. This is the given quadratic equation. This quadratic equation is of the form x square minus alpha square. So the first thing you will notice is that the coefficient of x has to be equal to 0. So p plus q minus 2r is equal to 0, or the value of r is p plus q divided by 2. The second thing is the constant term. This is of the form minus alpha square. Therefore, pr plus qr minus pq is equal to alpha square. This is p plus q into r minus pq. This is the value of alpha square. P plus q into r, because r is p plus q by 2, this is equal to p plus q into p plus q by 2 minus pq. This is p square plus q square plus 2pq divided by 2 minus pq. 2pq divided by 2 minus pq will be equal to 0. So this is effectively equal to p square plus q square by 2. This is the value of what? This is the value of alpha square. What are we required to calculate? What we are required to calculate is the value of 2 alpha square. We are required to calculate the sum of the squares. So this would imply that the value of 2 alpha square will be p square plus q square. So the answer for this particular question is option A, which is p square plus q square. In this question, we are told that f of x is a quadratic expression such that f of 1 plus f of 2 is equal to 0, and minus 1 is a root of the quadratic equation f of x is equal to 0. We are required to calculate the other root of f of x is equal to 0. Let us assume that f of x is equal to k into x minus of minus 1, which is x plus 1 into x minus p. For this, the two roots will be minus 1 and p. We are required to calculate the value of p. What do we know? We know that f of 1 plus f of 2 is equal to 0. What is f of 1? F of 1 is k times 1 plus 1 is 2 into 1 minus p. This is k times 2 minus 2p. What is f of 2? F of 2 is k times, we'll just substitute the value of x to be equal to 2. 2 plus 1, which is 3, into 2 minus p. This is k times 6 minus 3p. The sum of these two is equal to 0. So 2 minus 2p plus 6 minus 3p is equal to 0, or 8 minus 5p is equal to 0, or the value of p is 8 divided by 5. So the answer for this particular question is option D, which is 8 by 5. In this question, we are asked to calculate the number of integral values for which the quadratic expression 1 plus 2m into x square minus 2 into 1 plus 3m into x plus 4 into 1 plus m is always positive. Now, how does a quadratic equation look like? If you have a quadratic equation, it is either upward sloping or downward sloping. If it is a upward sloping parabola, it will be something like this. This is always positive because this is the x-axis and the quadratic equation is always greater than the x-axis. Or it can be like this. Here it will have two roots, this one and this one, and in this particular area the quadratic equation is negative. Or it can just touch the axis, something like this, where it is 0 at one point, but at every other point it is positive. This is if it is an upward sloping parabola. Sometimes if the coefficient of x square is negative, it will be a downward sloping parabola. It will be either like this, or it will touch like this, or it is always negative. Now when the coefficient of x square is negative, the parabola will be definitely below the x-axis at some point. So if you have a quadratic equation which is of the form ax square plus bx plus c, if a is less than 0, it will be one of these three, and definitely at some point it is below the x-axis. So you will not have a situation where the quadratic equation is always above the x-axis. So this is not what we are talking about. It has to be one of this, where the value of a is greater than 0. The coefficient of x square has to be greater than 0, and amongst these three, we are looking for the case where the quadratic equation is always positive. It is not this, because like we discussed, in this area, the quadratic equation is negative. It is also not this, because at this particular point, the quadratic equation is equal to 0. We are specifically looking at this particular case. Now, when does this happen? This will happen if the discriminant d is less than 0. Because we want the quadratic equation to have no real roots. Then it will always be positive. So there are two conditions that are needed. First, the coefficient of x square has to be greater than 0. The second one is that the discriminant of the quadratic equation has to be less than 0. If you are looking at the coefficient of x square, it is 1 plus 2m. So the first condition we want is 1 plus 2m has to be greater than 0, or m has to be greater than minus 1 by 2. The second condition is that the discriminant has to be less than 0. What is the discriminant? The discriminant is b square minus 4ac. What is b square? It is 2 into 1 plus 3m whole square has to be less than 4 into 1 plus 2m. This is the coefficient of x square into the constant term. The constant term is 4 times 1 plus m. If you are simplifying it, we can cancel, because 2 square will be 4, we can cancel it. So we have 3m plus 1 whole square, which is 9m square plus 6m plus 1. This has to be less than 4 times 2m square plus 3m plus 1. Or we want m square minus 6m, this is plus 1, has to be less than 3. This is the condition that we want. You will see that we can't easily factorize m square minus 6m minus 3. So what we'll instead do is, we'll add 9 here and we'll add 9 here. So we want m square minus 6m plus 9 to be less than 12. But m square minus 6m plus 9 is m minus 3 whole square. So we want m minus 3 whole square to be less than 12, or m minus 3 has to lie between square root of 12 and minus square root of 12. Therefore, m has to lie between 3 plus square root of 12 to 3 minus square root of 12. Now, we are looking only for integral values. Square root of 12 is approximately 3.5. So basically what we are saying is m has to be less than 6.5 and greater than minus 0.5. So the values m can take are 0, 1, 2, 3, 4, 5 and 6. So m can take 7 values. So the answer for this particular question will be option A, which is equal to 7. In this question, we are told that lambda be the ratio of the roots of the quadratic equation in x, which is 3m square x square plus m times m minus 4 into x plus 2 is equal to 0. Then the least value of m for which lambda plus 1 by lambda is equal to 1 is supposed to be calculated. Now, let us assume that the two roots are p and q. So the value of p plus q, which is the sum of the roots, is equal to minus of m into m minus 4, which is minus of the coefficient of x divided by 3m square, which is the coefficient of x square. And the value of the product of the roots p into q is equal to the constant term, which is 2 divided by 3m square, which is the coefficient of x square. Now, what exactly is lambda? Lambda is the ratio of the roots, which will be basically p by q. Now, if you are given lambda and we are given some equation in lambda, the equation that we are basically given is lambda plus 1 by lambda is 1. That is what we are told is p by q plus q by p is equal to 1, or we have p square plus q square divided by pq is equal to 1. Now, once you see p square plus q square divided by pq, you should immediately think of p plus q whole square. So, for example, if I am adding 2 to both sides, p square plus q square plus 2pq divided by pq will be equal to 3. This is p plus q whole square divided by pq is equal to 3. This is given to us. We know the value of p plus q. We know the value of pq. So p plus q whole square is equal to m square into m minus 4 whole square divided by 9m to the power 4. You can simplify this. This is m minus 4 whole square divided by 9m square. This is p plus q whole square and this is pq. What is the ratio of p plus q whole square divided by pq? This will be m minus 4 whole square divided by 9 whole divided by 2 by 3. Because the m square in the denominator over here and the m square in the denominator over here will get cancelled. So this is equal to m minus 4 whole square divided by 6. This is the value of p plus q whole square divided by pq. That we are told is equal to 3. So m minus 4 whole square is equal to 18. So m minus 4 is either square root of 18 or m minus 4 is minus square root of 18. Or the value of m is either 4 plus square root 18 or 4 minus square root 18. This is 4 plus 3 times square root 2 or 4 minus 3 times square root 2. If you're looking at the options, what we are asked to calculate is the least value. So the answer will be 4 minus 3 times square root 2. In this question, we are told that one real root of the quadratic equation 81 x square plus kx plus 256 is the cube of the other root, then the value of k is. So if you assume that one of the roots is p, the second root will be pq. What is the sum of the roots of this polynomial? Sum of the roots will be p plus pq, and this is equal to minus k by 81. Because sum of the roots of a quadratic equation is minus of the coefficient of x divided by the coefficient of x square. And what is the product of roots? Product of roots is equal to p into pq, which is p to the power 4, and that is equal to 256 by 81. because the product of roots is equal to the constant term divided by the coefficient of x square. So in this particular case, if p to the power 4 is equal to 256 by 81, p square is equal to 16 by 9, which is the square root of 256 by 81. And the value of p is either 4 by 3 or p is equal to minus 4 by 3. We have another equation, p plus p cube is minus k by 81. So p into, we can write it outside actually, p into 1 plus p square is equal to minus k by 81. What is p square? P square is 16 by 9. In both the cases, p square is 16 by 9. So p into 1 plus 16 by 9 is 25 by 9 is equal to minus k by 81. This is 9. Or the value of k is equal to minus 225p. So in this particular case, if p is 4 by 3, the value of k is minus 225 into 4 by 3, which is minus 300. In this case, if p is minus 4 by 3, the value of k is minus 4 by 3 into 225. This is minus of minus 225. So this is equal to 300. So basically the value of k is either minus 300 or plus 300. Amongst the options, we only have minus 300. So we are going to mark that and go ahead. In this question, we are given an equation. We are required to calculate how many roots the equation has, which is 3 to the power x into 3 to the power x minus 1 plus 2 is equal to modulus of 3 to the power x minus 1 plus 3 to the power x minus 2. So to simplify it and to exactly understand what exactly is given, let us assume that 3 to the power x is a new variable. Let us say it is equal to y. So the equation we have is y into y minus 1 plus 2 is equal to modulus of y minus 1 plus modulus of y minus 2. This has two modulus, so there will be three intervals and there will be two critical points. What are the two critical points? The two critical points at which the modulus will change its sign is when y is equal to 1 or when y is equal to 2. So let us consider three cases. The first case is y is less than or equal to 1. The second one is 1 is less than y is less than 2. And the third case is when y is greater than or equal to 2. These are the three cases we have to consider. If say y is greater than or equal to 2, all the modulus are positive, all the terms inside the modulus. So the equation becomes y square minus y plus 2 is equal to y minus 1 plus y minus 2. Or this becomes equal to y square minus 3y plus 5 is equal to 0. This is y square minus 3y plus 5 is equal to 0. If you are looking at this equation, this is a quadratic equation. What is the discriminant of this quadratic equation? The discriminant is 9, which is 3 square, minus 4 into 5, which is minus 11. This is less than 0. So this has no real roots. So we can ignore this case. If y lies between 1 and 2, then y minus 1 is positive, but y minus 2 is negative. So the equation becomes y square minus y plus 2 is equal to y minus 1 plus 2 minus y. Or y square minus y plus 2 is equal to, these two get cancelled, is equal to 1. Or y square minus y plus 1 is equal to 0. This is also another quadratic equation. And what are the roots of this quadratic equation? Both the roots will be complex, because what is the discriminant? The discriminant is 1 square minus 4 into 1, which is equal to minus 3. This also is less than 0. Whenever the discriminant of a quadratic equation is less than 0, it will have no real roots. So this also has no real roots. Finally, let us look at the last case where y is less than or equal to 1. then y minus 1 is negative, y minus 2 is negative, and the quadratic equation becomes y square minus y plus 2 is equal to 1 minus y plus 2 minus y, or y square 1 minus y and this 2 get cancelled. This is y square plus y, these 2 get cancelled, minus 1 is equal to 0, or the value of y is minus 1 plus or minus square root of b square is 1 plus 4 divided by 2. So there are two values for y, either it is minus 1 minus square root of 5 by 2 or minus 1 plus square root of 5 by 2. But what is y? Y is 3 to the power x. 3 to the power x is always greater than 0. 3 to the power any number is a positive number. It will not be negative. Minus 1 minus square root of 5 by 2 is a negative number. So that is an extraneous root. We can ignore it. The only root we have is 3 to the power x is square root of 5 minus 1 by 2, or the value of x is log of square root of 5 minus 1 by 2 to the base 3. This is the only root of the given quadratic equation. So the root is a singleton, which is option B.
Sometimes concept మీకు తెలుసు బట్ క్వశ్చన్ చూస్తే సాల్వ్ అవ్వదు. అప్పుడు మీకు కొంచెం ఎక్స్ట్రా కావాలి. క్వశ్చన్ని చూడడానికి ఒక ఎక్స్ట్రా పర్స్పెక్టివ్, మీరు రిపీటెడ్గా మిస్టేక్స్ చేస్తున్న టాపిక్స్లో ఎక్స్ట్రా ప్రాక్టీస్, కాన్సెప్ట్ చదివిన తర్వాత కూడా స్టక్ అయితే ఎక్స్ట్రా క్లారిటీ. అండ్ ఆ ఎక్స్ట్రా పర్స్పెక్టివ్ని ఎవరు బెటర్గా ఇవ్వగలరు? JEE AIR 29తో IIT బాంబే CSE క్రాక్ చేసిన మారుతి సార్ అలాంగ్ విత్ 15+ years నుంచి స్టూడెంట్స్కి మ్యాథ్ టీచ్ చేస్తున్న రాధాకృష్ణ సార్. Cracku JEE Maths course is designed by Maruti Sir and taught by రాధాకృష్ణ సార్. టఫ్ క్వశ్చన్ని ఎలా చూడాలి, ఎక్కడ స్టార్ట్ చేయాలి, అప్రోచ్ని ఎలా బిల్డ్ చేయాలి అవి నేర్చుకోండి. Cracku JEE Maths కోర్స్ మీ ప్రిపరేషన్కి ఒక లిటిల్ ఎక్స్ట్రా పుష్. లింక్ ఇన్ ద డిస్క్రిప్షన్.
In this question, we are told that f of x is a quadratic polynomial such that f of minus 1 plus f of 2 is equal to 0. One of the roots of f of x is equal to 0 is 3, then the other root lies in. So let us assume that f of x is some constant k into x minus 3 into x minus say p. Why are we writing it like this? Because we know that one of the roots is 3. So when x is equal to 3, this function will be equal to 0. We don't know the coefficient of x square. It can be 1 or 2. So we'll write it as k times x minus 3 into x minus p. We're also told that f of minus 1 plus f of 2 is equal to 0. What is f of minus 1? For f of minus 1, you just substitute the value of x to be minus 1. So this will be k times, this will be minus 4 into minus 1 minus p. And f of 2 is 0. What is f of 2? F of 2 will be k times 2 minus 3 is minus 1 into 2 minus p. The sum of these two is 0. So you can write this as 4 times 1 plus p, this one, plus p minus 2 is equal to 0. We can cancel k because everything is equaling 0. So this is 4p plus 4 plus p minus 2 is equal to 0, or 5p is equal to minus 2. So the value of p is minus 0.4. So the second root will be minus 0.4. So it will lie between minus 1 and 0, which is option A. What is the least positive value of A for which the equation 2x square plus a minus 10x plus 33 by 2 is equal to 2a has real roots? Okay. The equation is 2x square plus a minus 10x plus 33 by 2 is equal to 2a has real roots. If you are given a quadratic equation which is of the form ax square plus bx plus c is equal to 0, for every quadratic equation which is of this form, there is something called a discriminant. Let us call the discriminant d. D is b square minus 4ac. That is the square of the coefficient of x minus 4 times the coefficient of x square into the constant term. If d is greater than 0, this equation has two real roots. That is, both the roots are real and they are not equal to each other. If D is equal to 0, it has one real root. Basically, it has two roots, but both of them are equal to each other. Something like, in this particular case, it will be a perfect square. Like say x minus 4 whole square. If x minus 4 whole square is equal to 0, x is equal to 4. There is only one real root. In the first case, it will be of the form x minus 2 into x minus 5 is equal to 0. So the value of x is either 2 or 5. In the third case, if D is less than 0, it will have no real roots. How does that look like? The equation will look something like, say, x square plus 5 is equal to 0. Now you know that x square is non-negative. X square is always greater than or equal to 0. So something which is non-negative plus 5 cannot be equal to 0. There is no real value of x for which this is true. So that is the importance of calculating the discriminant. In this particular case, we are given a quadratic equation, which is 2x square plus a minus 10 into x plus 33 by 2 is equal to 2a. That is, if you are writing it down, it is 2x square plus a minus 10 into x plus 33 by 2 minus 2a. This is equal to 0. This is the quadratic equation we have. And we want this quadratic equation to have real roots. For this to have real roots, we want the discriminant to be greater than 0. When would that happen? You want b square, which is a minus 10 whole square, to be greater than or equal to 4 times ac. What is a, which is the quotient of x square? It is 2. Into what is c, which is the constant term? It is 33 by 2 minus 2a. This is a square minus 20a plus 100 is greater than or equal to 8 times 33 by 2 is 132. That will be 33 into 4 minus 16a. You can simplify this to equal a square minus 4a minus 32 is greater than or equal to 0. This is a minus 8 into a plus 4 is greater than or equal to 0. So either a has to be less than minus 4, less than or equal to, or a has to be greater than or equal to 8. These are the two cases that are needed, in which case a minus 8 into a plus 4 is greater than or equal to 0. What are we required to calculate? We are required to calculate the least positive value of a. The least positive value of a will be in this interval, and that will equal 8. So the answer for this question is, the smallest positive value that a can take is 8. This question we are told that alpha and beta are the two roots of the equation x square minus 64x plus 256 is equal to 0. As alpha and beta are the roots of this equation, the sum of the roots alpha plus beta will be minus of the coefficient of x. So alpha plus beta is 64. Alpha into beta is the constant term, which is 256. What are we required to calculate? We are required to calculate alpha cube by beta to the power 5 to the power 1 by 8 plus beta cube divided by alpha to the power 5 to the power 1 by 8. So what we are required to calculate is alpha to the power 3 by 8 divided by beta to the power 5 by 8 plus beta to the power 3 by 8 divided by alpha to the power 5 by 8. This is if you are bringing a common denominator, which is alpha to the power 5 by 8 into beta to the power 5 by 8. This is alpha plus beta. This is equal to alpha plus beta divided by alpha beta to the power 5 by 8. Alpha plus beta is equal to 64. So this is equal to 64 divided by alpha beta is 256. So this is 256 to the power 5 by 8. This is 64 divided by 256 to the power 1 by 8 is 2, because 256 is 2 to the power 8. So the denominator is equal to 2 to the power 5, which is 64 divided by 32, which is equal to 2. So the answer for this particular question is 2 which is option A. In this question, we are told that alpha and beta are the roots of the equation 5x square plus 6x minus 2 is equal to 0. S of n is given as alpha to the power n plus beta to the power n, and n is 1, 2, 3 dot dot dot. Then we have to calculate which of the four equations is valid. Alpha and beta are the roots of this equation. So 5 alpha square plus 6 alpha minus 2 is equal to 0. Similarly, 5 beta square plus 6 beta minus 2 is equal to 0. If you multiply this with alpha to the power n, we are going to get 5 to the power 5 into alpha to the power n plus 2 plus 6 times alpha to the power n plus 1 is equal to 2 times alpha to the power n. If you multiply this equation with beta to the power n, we are going to get 5 times beta to the power n plus 2 plus 6 times beta to the power n plus 1 is equal to 2 times beta to the power n. Now we know that S of n is alpha to the power n plus beta to the power n. If you are adding both of these equations, this equation plus this equation, we are going to get 5 times alpha to the power n plus 2 plus beta to the power n plus 2 plus 6 times alpha to the power n plus 1 plus beta to the power n plus 1 is equal to 2 times alpha to the power n plus beta to the power n. This is S of n plus 2. So 5 times S of n plus 2 plus this is 6 times S of n plus 1 is equal to 2 times S of n. This is true for all values of n. If you are looking at the options that are given, and if you substitute the value of n to be equal to 4, we will get 5 times S of 6 plus 6 times S of 5 is equal to 2 times S of 4. So if you're looking at which of the options is correct, that will be option C. In this question, we are given that alpha and beta are the roots of the quadratic equation x square minus 3x minus 2 is equal to 0. And the value of alpha divided by 1 minus alpha square plus beta divided by 1 minus beta square is required to be calculated. If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, and if it has two roots p and q, the value of p plus q is minus b by a. The value of p into q is c by a. So in this particular question, the value of the sum of the roots alpha plus beta is 3 by 7. And the value of alpha into beta, which is the product of the roots, is minus 2 by 7. What are we required to calculate? We are required to calculate alpha divided by 1 minus alpha square plus beta divided by 1 minus beta square. If you are simplifying this and taking a common denominator of 1 minus alpha square into 1 minus beta square, the numerator will be alpha into 1 minus beta square plus beta into 1 minus alpha square. Let us first calculate the value of the numerator and then calculate the value of the denominator. The numerator will be alpha minus alpha beta square plus beta minus beta alpha square. This is alpha plus beta minus, for these two terms, if you are taking alpha beta common, this is alpha plus beta. What is alpha plus beta? Alpha plus beta is 3 by 7. So this is 3 by 7 minus, what is alpha beta? It is minus 2 by 7. So this is minus 2 by 7 into alpha plus beta is again 3 by 7. So the numerator is simply equal to 3 by 7 plus 6 by 49, which is 27 by 49. This is the numerator. What about the denominator? The denominator is 1 minus alpha square into 1 minus beta square. 1 minus alpha square into 1 minus beta square. This is 1 minus alpha into 1 plus alpha. This is 1 minus alpha square into 1 minus beta into 1 plus beta. If you are combining these two and these two, and if you are expanding the product, if you are combining 1 minus alpha into 1 minus beta, and you are combining 1 plus alpha into 1 plus beta. What is 1 minus alpha into 1 minus beta? This will be 1 minus alpha minus beta plus alpha beta. What is 1 plus alpha into 1 plus beta? This is 1 plus alpha plus beta plus alpha beta. This is 1 minus, what is alpha plus beta? Alpha plus beta is 3 by 7. So this is 1 minus 3 by 7 and alpha beta is minus 2 by 7 into 1 plus 3 by 7 minus 2 by 7. This is 2 by 7 into 8 by 7. This is 16 by 49. This is the denominator. This is the numerator. Therefore, numerator divided by denominator is 27 divided by 16. So the answer for this particular question is option D, which is 27 divided by 16. In this question, we are told that A and B belong to real numbers. A is not equal to 0, such that the equation ax square minus 2bx plus 5 has a repeated root, which is also a root of x square minus 2bx minus 10 is equal to 0. Beta is the other root of this equation, then alpha square plus beta square is equal to what? To solve this, let us first understand what is a repeated root. Whenever you say that a quadratic equation, which is of the form ax square plus bx plus c is equal to 0, has a repeated root, it implies that the discriminant of this quadratic equation is 0. Or this quadratic equation is kind of a perfect square. This is of the form a into x minus p whole square is equal to 0. So that both the roots of this quadratic equation are the same. That is what we call by when we say that this is a repeated root. For example, if you are looking at a quadratic equation, if a is greater than 0, it will be an upward sloping parabola. It will be something like this. Here it has two roots. This is one root and this is another root. If it is a parabola like this, which is touching the x-axis, it has only one root. And if it is a parabola like this, which is above the x-axis, it is not touching the x-axis, it has no real root. What is the discriminant of this given quadratic equation? The discriminant D is b square minus 4ac. Now, in the first case, where it is touching the x-axis at two places, the discriminant D is greater than 0. In the second case, when it is touching the x-axis at only one place, the discriminant D is equal to 0. This kind of a parabola is, like I mentioned, something like a perfect square. If you have a quadratic equation which is something like, say, x minus 2 whole square is equal to 0, x has to equal 2. There will be two roots, but both of them will be equal to 2. And in the third case, if the parabola is above the x-axis, the discriminant D is less than 0. It will have no real roots. This is something like x square plus 5 is equal to 0. X square is always greater than or equal to 0, plus 5 will be definitely greater than or equal to 5. This will have no real roots. What we are talking about is this particular case. We are talking about the case where both the roots are equal to each other, and so the discriminant is equal to 0. That is one thing. Now, what is this point? What is the value of x? That point is the point at which the quadratic equation will attain its minimum. For any quadratic equation, the minimum value will be when x is equal to minus b divided by 2a. This is the point at which the quadratic equation will attain its minimum. So based on what is told to us, let me clear this so that we can start over again. This is the quadratic equation. This has a repeated root. So the discriminant of this quadratic equation is 0. What is the discriminant? It is square of the coefficient of x, which is 4b square, is equal to 20 times a, which is 4 into a into 5, which is 28. Or the value of a is b square by 5. This is the value of a. Now we are also told that alpha is the repeated root. The repeated root is the point at which the quadratic equation will attain its minimum. So alpha is equal to minus of the coefficient of x, which is minus 2b, divided by 2 times the coefficient of x square, which is a. So this is equal to b by a. This is the value of alpha. A is b square by 5. So alpha is equal to b divided by b square by 5, which is equal to 5 by b. This is the value of alpha. We are told that this is also a root, alpha is also a root of the second equation. If alpha is also a root of the second equation, instead of x, we'll substitute alpha. So this will be 5 by b whole square minus 2 times b into 5 by b minus 10 is equal to 0. Or this is 25 by b square minus 10 is equal to 0. Or b square is equal to 25 by 20, which is equal to 5 by 4. So we know the value of b, it is square root of 5 by 4 or minus square root of 5 by 4. What are we asked to calculate? We are told that the other root is beta, and we are asked to calculate alpha square plus beta square. If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, what is the sum of roots? Sum of roots is minus b by a. What is the product of roots? Product of roots is equal to c by a. In this quadratic equation, the sum of the roots is alpha plus beta. This is 2b, which is minus of coefficient of x. And alpha beta is equal to minus 10. Using this two, we can calculate alpha square plus beta square. If you are squaring this equation, we are going to get alpha square plus beta square plus 2 alpha beta is equal to 4b square. Alpha beta is minus 10. So alpha square plus beta square minus 20 is equal to 4b square. Or alpha square plus beta square is 4b square plus 20. But what is the value of b square? B square is 5 by 4. Therefore 4b square is equal to 5. And therefore 4b square plus 20 will be 25. Therefore the answer for this particular question is option A, which is 25. In this question, we are asked to consider two sets. The first set is A such that the two roots of the quadratic equation x square minus m plus 1 into x plus m plus 4 are real. And the second one is B, which is minus 3 to 5. Here we have a square bracket to the left of minus 3, so minus 3 is included. And we have a curved bracket to the right of 5, so 5 is not included. Quickly letting you know, if you have something like the interval a comma b, a is part of it, b is part of it. If you have something like a comma b, where both of them are curved, a is not part of it, b is not part of it. Suppose you have something like this, a and b, there is a square bracket to a and a curved bracket to b, a is part of it, b is not part of it. Now if you're looking at the quadratic equation which is going to define a, we have x square minus m plus 1 into x plus m plus 4 is equal to 0. If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, the discriminant of this quadratic equation is b square minus 4ac. If the discriminant is greater than or equal to 0, both the roots are real. If the discriminant is less than 0, it will have two complex roots. Here we are asked to calculate this part because we wanted this equation to have two real roots. So the discriminant of this quadratic equation has to be greater than or equal to 0. What is the discriminant? It is m plus 1 whole square minus 4 times m plus 4. This has to be greater than or equal to 0. Or m square plus 2m plus 1 minus 4m minus 16 has to be greater than or equal to 0. Or m square minus 2m minus 15 is greater than or equal to 0. This is m minus 5 into m plus 3 is greater than or equal to 0. This is what has to happen for the quadratic equation to have real roots. Therefore, m has to be either less than or equal to minus 3 or m has to be greater than or equal to 5. So the interval of a is minus infinity to minus 3. We will have a square bracket because 3 is included. Union 5 to infinity. This is the value of the bracket A. And that of bracket B is given, the set B is minus 3 to 5. Now let us look at all the 4 options. The first option is A minus B. When we are talking about A minus B, we want the elements which are part of A and not part of B. Minus infinity to minus 3 is part of A, it is not part of B. But 3 is part of B. Therefore, A minus B will be minus infinity to minus 3. But minus 3 will not be part of it. Because even though minus 3 is part of A, minus 3 is also part of B. So A minus B will not include minus 3. If you are looking at 5 to infinity, 5 to infinity is part of A and not part of B. Even 5, look at it over here, we have a curved bracket. So 5 is not part of B and 5 is part of A. So A minus B will be union 5 to infinity. If you're looking at the option, here we have a curved bracket. So the option A says that 5 is not part of A minus B, but this is false. Because 5 is part of A minus B. We will have a square bracket here. Let us look at the second option. A intersection B. A intersection B should include all the elements which are part of A and part of B. The only element which is common is 3. Because A has all the terms less than or equal to minus 3. B has minus 3 to 5. A has 5 to infinity. The only common thing is 3. So A minus B is minus 3. That is the only element. So option B is true. If you are looking at option C, what is B minus A? B minus A should include all the terms which are part of B and not part of A. So minus 3 to 5 will be part of B but not part of A. But 3 is part of both. Minus 3 is part of both B as well as A. So minus 3 will not be part of B minus A because minus 3 is part of A. So B minus A will be minus 3 to 5. Note that it will be curved here because even though minus 3 is part of B, because it is part of A also, it will not be part of B minus A. So this is true. Last is A union B. So if you're looking at A union B, A union B will include all the terms which are part of either A or that of B. A has minus 3 to minus infinity to minus 3. B has minus 3 to 5. C has 5 to infinity. So all of them are part of either A or B or both. So the correct answer is, it is real. So option D also is true. So 3 options are true. This is true, this is true, and this is true. The only option which is not true, which is what we are required to calculate, is option A. In this question, we are told that we are given an equation, we are asked to calculate the product of the roots of the equation. The equation is 9x square minus 18 times modulus of x plus 5 is equal to 0. Let us assume that modulus of x is equal to p. Therefore, x square, which will be modulus of x whole square, is equal to p square. So this given quadratic equation is 9p square minus 18p plus 5 is equal to 0. Or this is 9p square minus 15p minus 3p plus 5 is equal to 0. this is 3p minus 1 into 3p minus 5 is equal to 0. So the value of p is either 1 by 3 or the value of p is 5 by 3. But what is p? P is modulus of x. So modulus of x is either 1 by 3 or modulus of x is 5 by 3. So x is minus 1 by 3 or 1 by 3 or minus 5 by 3 or 5 by 3. These are the four values that x can take. And what is the product of these roots? 1 by 3 into minus 1 by 3 is minus 1 by 9. 5 by 3 into minus 5 by 3 is minus 25 by 9. So the overall product is 25 divided by 81. So the answer for this particular question is option B, which is 25 by 81. In this question, we are asked to calculate the number of real roots of the equation e to the power 4x plus e to the power 3x minus 4 times e to the power 2x plus e to the power x plus 1 is equal to 0. We have a lot of e to the power x's here. Let us assume that e to the power x is a variable, say t. So e to the power 2x is t square, e to the power 3x is t cube, and e to the power 4x is t to the power 4. What can we say about e to the power x? E to the power x is always going to be a number which is greater than 0. E to the power x will not be a negative number. E to the power of any number will always be greater than 0 because e is a positive number. So the given equation becomes equal to t to the power 4 plus t cube minus 4t square plus t plus 1 is equal to 0. In this equation, if you put t is equal to 1, we are going to get 1 plus 1 plus 1 plus 1 minus 4, which is equal to 0. This would imply that t minus 1 is a factor of this given polynomial. So we can write this as t to the power 4 minus t cube plus 2t cube minus 2t square minus 2t square plus 2t minus t plus 1 is equal to 0. This is the same as the earlier one. We have just expressed it such that from every pair we are going to take t minus 1 common. For example, from these two, it will be t cube into t minus 1. From these two, it is 2t square into t minus 1. From these two, it is minus 2t into t minus 1. And over here, it is minus 1 into t minus 1. This is equal to 0. Or this is t cube plus 2t square minus 2t minus 1 into t minus 1 is equal to 0. In this cubic equation, again if you put t is equal to 1, it will be 1 plus 2 minus 2 minus 1. Again it is equal to 0. So again t minus 1 has to be a factor of this cubic equation. So let us express this as t cube minus t square plus 3t square minus 3t plus t minus 1 into t minus 1. We'll do the same thing. Again we are going to get this as t square plus 3t plus 1 into t minus 1 into t minus 1 is equal to 0. These two will be equal to 0 if t is equal to 1. This is a quadratic equation. It has two roots. If you're looking at the quadratic equation, if you assume that the two roots are p and q, p plus q is equal to minus 3. P into q is equal to 1. The sum of the roots of this given quadratic equation is minus 3. The product is equal to 1. So p and q, both of them have to be negative. Because the product is positive, either both of them are positive or both of them are negative. But the sum is negative, so both of them have to be negative. So this will have two roots, but both of them are negative. And we know that t has to be greater than 0. So this will have no valid answer for e to the power x. And the remaining two is t is equal to 1 or e to the power x is equal to 1 or x is equal to 0. This is a valid value. So the entire equation has only one solution, and that is x is equal to 0. So the correct answer is option A. In this question, we are told that alpha and beta are two real numbers such that alpha plus beta is equal to 1 and alpha beta is equal to minus 1. So if you have alpha plus beta is equal to 1 and alpha beta is equal to minus 1, if you are trying to create a quadratic equation with alpha and beta as the roots, the quadratic equation will be x square minus alpha plus beta into x plus alpha beta is equal to 1. This is the quadratic equation which has alpha and beta as the roots. So the quadratic equation becomes equal to x square minus x minus 1 is equal to 0. This is the quadratic equation whose roots are alpha and beta. This would imply that alpha square minus alpha minus 1 is 0, and similarly beta square minus beta minus 1 is equal to 0. We have p of n, which is alpha to the power n plus beta to the power n. So if you multiply the first equation with alpha to the power n and you multiply the second equation with beta to the power n, what do you get? We get alpha to the power n plus 2 minus alpha to the power n plus 1 is equal to alpha to the power n. I've just taken this one to the other side. And the second one will be beta to the power n plus 2 minus beta to the power n plus 1 is equal to beta to the power n. If I add both of these equations, what am I going to get? If I'm adding both of these equations, I'll get alpha to the power n plus 2 plus beta to the power n plus 2 minus alpha to the power n plus 1 plus beta to the power n plus 1 is equal to alpha to the power n plus beta to the power n. Now this is p of n plus 2 minus p of n plus 1 is equal to p of n. This is true for all values of n. That is p of n plus 2 and p of n plus 1. Suppose you substitute instead of n the value of n minus 1. Then p of n minus 1 is equal to p of n plus 1 minus p of n. Or the value of p of n is equal to p of n plus 1 minus p of n minus 1. Again, this is true for all values of n. For one particular value of n, we are told that p of n minus 1 is 11 and p of n plus 1 is 29. So p of n will be 29 minus 11, which is 18. And p of n whole square is 18 square, which is 324.
JEE AIR 29 and 15+ years experience ఉన్న మ్యాథ్ టీచర్ కలిసి ఒక JEE మ్యాథ్స్ కోర్స్ డిజైన్ చేస్తే ఎలా ఉంటుంది? యూ గెట్ ద బెస్ట్ ఆఫ్ బోత్ సైడ్స్. JEE క్రాక్ చేయడానికి ఏం కావాలో తెలిసిన పర్సన్ అండ్ స్టూడెంట్స్ ఎక్కడ స్టక్ అవుతారో ఎగ్జాక్ట్లీ తెలిసిన టీచర్. సో ఇక్కడ మీరు జస్ట్ ఫార్ములాస్ నేర్చుకోరు, కాన్సెప్ట్ని అండర్స్టాండ్ చేసుకుంటారు, క్వశ్చన్ని ఎలా అప్రోచ్ చేయాలో నేర్చుకుంటారు, ప్రాక్టీస్ చేస్తారు అంటిల్ ఇట్ క్లిక్స్. అండ్ ఎగ్జామ్ లైక్ కండిషన్స్లో మిమ్మల్ని మీరు టెస్ట్ చేసుకుంటారు. 150+ కాన్సెప్ట్ వీడియోస్, 150+ కాన్సెప్ట్ టెస్ట్, 400 టాపిక్ టెస్ట్, 15 full-length mocks designed by IIT JEE AIR 29 Maruti Sir and taught by Radhakrishna Sir with 15+ years of teaching experience. Learn, practice, apply. Check out the Cracku JEE Maths course, link in the description.
In this question, we are told that alpha and beta are the roots of the equation x square plus 5 root 2x plus 10. Alpha is greater than beta. And p of n is a function which is alpha to the power n minus beta to the power n for each positive integer n. We are required to calculate the value of an expression. If you are looking at the numerator is p of 17 into p of 20 plus 5 root 2 into p of 17 into p of 19. The first thing you will notice is if I take p of 17 common, I have p of 20 plus 5 root 2 into p of 19. This is the numerator. What about the denominator? If you are looking at the denominator is p of 18 into p of 19 plus 5 root 2 into p of 18 square. Again, if you take P of 18 common, you are getting P of 19 plus 5 root 2 into P of 18. This should give you an idea. This should give you an idea about how to proceed in these kind of questions. The idea is that this is of the form P of n plus 1 plus 5 root 2 into P of n. This also is of the form P of n plus 1 plus 5 root 2 into P of n. So let us look at what exactly is given. Alpha and beta are roots of this equation. So alpha square plus 5 root 2 alpha plus 10 is equal to 0. Similarly, beta square plus 5 root 2 beta plus 10 is equal to 0. Now if you multiply this with, say, alpha to the power n, and if you multiply this equation with beta to the power n, what are you going to get? You are going to get alpha to the power n plus 2 plus 5 root 2 into alpha to the power n plus 1 plus 10 times alpha to the power n is equal to 0. This is one equation. And from that, what is the other equation? From this one, beta to the power n plus 2 plus 5 root 2 into beta to the power n plus 1 plus 10 beta to the power n is equal to 0. Now if you add both of these equations, we'll have alpha to the power n plus 2 plus beta to the power n plus 2. If you add these two, you have 5 root 2 into alpha to the power n plus 1 plus beta to the power n plus 1. Plus, if you add these two, you have 10 times alpha to the power n plus beta to the power n. This is equal to 0. Now, what is alpha to the power n plus 2 plus beta to the power n plus 2? It is P of n plus 2. Plus this is 5 root 2 into P of n plus 1. And this is 10 times P of n. This is equal to 0. This is true for all values of n. So if you're looking at the numerator, what do we have in the numerator? We have P20 plus 5 root 2 P19. So if you're looking at this equation and you substitute n to be equal to 18, we will be having P20 plus 5 root 2 P19 plus 10 times P18 is equal to 0. So the numerator becomes equal to P17 into minus 10 times P18. Because P20 plus 5 root 2 times P19 is minus 10 times P18. If you're looking at the denominator, this is the denominator, it is P19 plus 5 root 2 times P18. And in the denominator, if you put n is equal to 17. In this equation, if you're putting n is equal to 17, you get P of 19 plus 5 root 2 P of 18 plus 10 times P of 17 is equal to 0. Therefore, the denominator becomes equal to, this is the denominator, P18, this will be minus 10 times P17. So the denominator is P18 into minus 10 times P17. If you look at the numerator and denominator, both of them are actually equal to the same number. And what is that number? That is equal to minus 10 times P17 into P18. This is the numerator and this is the denominator. Therefore, the fraction will be equal to 1. So the answer for this particular question is 1. In this question, we are asked to calculate the number of solutions of the equation log of x minus 1 to the base 4 is equal to log of x minus 3 to the base 2. First thing we should know is, when is a logarithm log of a to the base b defined? For this logarithm to be defined, we want a to be greater than 0, we want b to be greater than 0, and we want b to be not equal to 1. These are the conditions needed for the logarithm to be defined. In this case, for this equation to be defined, we want the arguments to be greater than 0. So we want x minus 1 to be greater than 0 and x minus 3 to be greater than 0. or we want x to be greater than 1 and x to be greater than 3. Both of them happen when x is greater than 3. So the condition that is needed is that x has to be definitely greater than 3. What is the second thing that is needed? You need to know a formula of log of a to the power m to the base b to the power n is equal to m by n into log of a to the base b. So the power of the argument, when it is brought outside the logarithm, comes in the numerator, and the power of the base, when it comes outside the logarithm, it comes in the denominator. Why is this important? Because now if you are looking at the equation that is given to us, this is log of x minus 1 to the base 4 is equal to log of x minus 3 to the base 2. Log of x minus 1 to the base 4 is equal to 1 by 2 into log of x minus 1 to the base 2 is equal to log of x minus 3 to the base 2. Now you send this to the other side of the equation, you are going to get log of x minus 1 to the base 2 is equal to 2 times log of x minus 3 to the base 2. If you are taking this 2 inside the logarithm, that will become equal to log of x minus 1 to the base 2 is equal to log of x minus 3 whole square to the base 2. Now you see that on both sides of the equation, the base of the logarithm is the same. So we can cancel this and we can cancel this. So you are going to get x minus 1 is equal to x square minus 6x plus 9, which is x minus 3 whole square. So you are going to get the equation as x square minus 7x plus 10 is equal to 0. This is x minus 5 into x minus 2 is equal to 0. So the two values that x can take are either 5 or x is equal to 2. But remember that for the logarithm to be defined, we needed x to be greater than 3. If x is less than 3, the logarithm is not defined and so the equation will not hold. Therefore, x cannot be equal to 2. The only value x can take is 5, like many of you mentioned in the chat. So I would say the correct answer is that only one value exists for x, which is equal to 5. In this question, lambda is not equal to 0, and we are told that alpha and beta are the roots of the equation. X square minus x plus 2 lambda is equal to 0. And alpha and gamma are the roots of the equation. 3x square minus 10x plus 27 lambda is equal to 0. We are required to calculate the value of beta into gamma divided by lambda. If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, and if the two roots of this given quadratic equation are p and q, then the sum of the roots p plus q is equal to minus b by a, and the product of the roots p into q is equal to c by a. So from the first equation, the two roots are alpha and beta. So alpha plus beta is equal to 1, and alpha into beta is equal to 2 lambda. From the second quadratic equation, the sum of the roots will be 10 by 3. Therefore, alpha plus gamma is equal to 10 by 3, and alpha into gamma is equal to 27 lambda divided by 3, which is 9 lambda. If you look at this equation and this equation, alpha into beta is 2 lambda, alpha into gamma is 9 lambda. If you divide one equation from the other, you are going to get alpha and alpha gets cancelled. Gamma divided by beta is 9 by 2, or gamma is equal to 4.5 beta. You substitute this in this particular equation. Alpha plus 4.5 beta is equal to 10 by 3, and the first equation is alpha plus beta is 1. You subtract one equation from the other, alpha and alpha gets cancelled. 4.5 beta minus beta is 3.5 beta. This is equal to 10 by 3 minus 1, which is 7 by 3. Or the value of beta is equal to 7 divided by 3 into 3.5, which is equal to 2 by 3. This is the value of beta. Alpha plus beta is 1. Therefore, the value of alpha is equal to 1 by 3. We have gamma, which is 4.5 times beta. So gamma is equal to 2 by 3 into 4.5, which is equal to 3. What is the value of lambda? Alpha into beta is 2 lambda. Alpha is 1 by 3, beta is 2 by 3, is equal to 2 times lambda, or the value of lambda is 1 by 9. What are we required to calculate? We are required to calculate beta into gamma divided by lambda. Beta is 1 by 3. Gamma is 3. Beta is actually 2 by 3. Beta is 2 by 3. Gamma is 3. And you have to divide this with lambda. Lambda is 1 by 9. So this is 2 divided by 1 by 9, which is equal to 2 into 9, which is equal to 18. So the answer for this particular question is 18. In this question, we are told that P and Q are two numbers such that P plus Q is 2 and P to the power 4 plus Q to the power 4 is 272. Then P plus Q are roots of the equation. If we are required to calculate the quadratic equation for which P and Q are the roots, we need to calculate the sum of roots, which is P plus Q, and the product of roots. What is the product of roots? The product of the roots is P into Q. These are the things that we need to calculate. P plus Q is already given to us. P plus Q is 2. So if we can calculate the product of the roots, we can answer this question. So we need to calculate P into Q. P plus Q is equal to 2. So P plus Q whole square is 2 square. P square plus Q square plus 2PQ is equal to 4. If you assume that the product of the roots P into Q is, say, T, P square plus Q square is 4 minus 2T. If you square it again, P to the power 4 plus Q to the power 4 plus 2 times P square Q square is 4 minus T whole square. But 2 times P square Q square is 2 times T square, because P into Q is equal to T. And P to the power 4 plus Q to the power 4 is given to us, that is equal to 272. So 272 plus 2 times T square is equal to 16. This is 4 minus 2T whole square plus 4T square minus, this is 4 minus 2T, this is 4 minus 2T whole square. This is 4 into 2 into 2, which is 16T. If you are simplifying it, you are going to get 2T square minus 16T minus 256 is equal to 0. Or T square minus 8T minus 128 is equal to 0. This can be factorized to equal T minus 16 into T plus 8 is equal to 0. Or the value of T is either equal to 16 or the value of T is equal to minus 8. That is, the product of P into Q is either equal to 16 or the product P into Q is equal to minus 8. We know the value of P plus Q. P plus Q is equal to 2. Therefore, the quadratic equation can be either x square minus 2x plus 16 is equal to 0, or x square minus 2x minus 8 is equal to 0. It can be either one of these two. If you're looking at the options that are given, we don't have x square minus 2x minus 8. Therefore, the correct answer will be x square minus 2x plus 16 is equal to 0. In this question, we are asked to calculate the number of solutions of the equation. Log of the argument is 2x square plus 7x plus 5 to the base x plus 1. And the second one is log of x plus 1 whole square to the base 2x plus 5. minus 4 is equal to 0. The first thing we'll do is we'll factorize this quadratic equation, which is 2x square plus 7x plus 5. This is equal to 2x square plus 2x plus 5x plus 5. This is equal to 2x plus 5 into x plus 1. So the given equation becomes equal to log of the base is x plus 1 and the argument is 2x plus 5 into x plus 1 plus log of the base is 2x plus 5 and the argument is x plus 1 whole square minus 4 is equal to 0. The first term can be simplified to equal log of x plus 1 to the base log of the first term can be simplified to equal log of x plus 1 to the base x plus 1, which is 1, plus log of 2x plus 5 to the base x plus 1. And the second term can be simplified to equal plus 2 times log of x plus 1 to the base 2x plus 5 minus 4 is equal to 0. Now if you assume that log of 2x plus 5 to the base x plus 1 is equal to p, this will become equal to 1 plus p plus 2 by p minus 4 is equal to 0. Or this is p plus 2 by p is equal to 3. This would imply that this is p square minus 3p plus 2 is equal to 0. This is p minus 1 into p minus 2 is equal to 0, or the value of p is either equal to 1 or the value of p is equal to 2. But what is p? P is log of 2x plus 5 to the base x plus 1. So either log of 2x plus 5 to the base x plus 1 is equal to 1, or log of 2x plus 5 to the base x plus 1 is equal to 2. One of these two has to be the case. This would imply that 2x plus 5 is equal to x plus 1, or the value of x is equal to minus 4. This would imply that 2x plus 5 is equal to x plus 1 whole square, which is x square plus 2x plus 1. This would imply that x square is equal to 4. So x is either 2 or x is minus 2. If you're looking at the equation which is given to us, the base is x plus 1. So if x is equal to minus 4 or if x is equal to minus 2, the base will be negative. Remember that if you have a logarithm which is of the form log of a to the base b, a has to be greater than 0, b has to be greater than 0, and b cannot equal 1. These are the three conditions that are needed for a logarithm to be defined. So if x is minus 4 or x is minus 2, the logarithm with base x plus 1 will not be defined. So the only solution for this is when x is equal to 2. Therefore, it has one real solution. In this question, we are asked to calculate the integer k, for which the inequality, if you're looking at the inequality, x square minus 2 times 3x minus 1 into x plus 8k square minus 7 is greater than 0 for all, for every value of x. What does this mean? If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0. In this particular case, a is 1, which is the quotient of x square. So let us assume, or let us talk about the case where a is greater than 0. Now, if you are drawing the graph of this quadratic equation, it will look something like this. It will be a upward sloping curve, which is called a parabola. Now, this can touch the x-axis either at 2 points, like this. This is one case. Or it can touch the x-axis at exactly 1 point, something like this. Or it can not touch the x-axis, like this. These are the three cases that are possible. In the first case, we say that the quadratic equation has two real roots. That is, at this point and at this point, the quadratic equation is equal to 0. So it has two real roots. Here we are going to say that it has one real root, because at only this one particular point is the quadratic equation equal to 0. And in this case, we say that it has no real roots, or it has two complex roots, because the quadratic equation is never equal to 0. Now, to determine whether it is this one or this one or this one, we need to calculate the discriminant. The discriminant of a quadratic equation is b square minus 4ac, which is the square of the coefficient of x minus 4 times the coefficient of x square and the constant term. In the first case, when it has two real roots, the value of the discriminant is greater than 0. When it has one real root, where it is just touching the x-axis, the value of the discriminant is equal to 0. And in this particular case, where it is always above the x-axis, it has no real roots. And we say that the discriminant d is less than 0. What we are talking about now is the third case. We want this quadratic equation to be always greater than 0. It should never be equal to 0. So therefore, the discriminant has to be less than 0. What is the discriminant of this given quadratic equation? It is 2 into 3k minus 1 whole square minus 4 times 8k square minus 7. We want this to be less than 0. Or you want 4 times 3k minus 1 whole square to be less than 4 times 8k square minus 7. You cancel 4 here, you cancel 4 here. This is 9k square minus 6k plus 1 is less than 8k square minus 7. Or we want k square minus 6k plus 8 to be less than 0. This is k minus 2 into k minus 4 is less than 0. So k should belong to 2, 4. And we are looking only for an integer solution. There is only one integer which lies between 2 and 4, and that is equal to 3. So the integer value of k is equal to 3, which is option C. In this question, we are asked to calculate the set of all the values of k which is greater than minus 1, for which the equation 3x square plus 4x plus 3 whole square minus k plus 1 into 3x square plus 4x plus 3 into 3x square plus 4x plus 2 plus k into 3x square plus 4x plus 2 whole square is equal to 0 has real roots. If you're looking at the equation, you would notice that there are a lot of terms which involve 3x square plus 4x plus 3. So let this be equal to a. And therefore 3x square plus 4x plus 2 will be a minus 1. So the given equation will be a square minus k plus 1 into 3x square plus 4x plus 3 is a, into 3x square plus 4x plus 2 is a minus 1, plus k into a minus 1 whole square is equal to 0. This is the equation that we have. We can split the middle term, so this will be a square. The middle term is k into a minus 1 minus a into a minus 1 plus k into a minus 1 whole square. This is equal to 0. Now if you are looking at a square minus a into a minus 1, this is simply equal to a. Minus, if you are taking this term and this term, you can take k into a minus 1 common. This will have a, this will have a minus 1. This is simply equal to 1. A minus 1 is 1. So basically what we have is a minus k times a plus k is equal to 0. This is the equation that we have. So if you substitute the value of a, which is 3x square plus 4x plus 3, 3x square plus 4x plus 3 minus k times 3x square plus 4x plus 3 plus k is equal to 0. This is a quadratic equation in x square. We can club all the coefficients of x square, x and the constant term. So for example, this will be x square into 3 minus 3k plus x into 4 minus 4k plus this is 3 minus 3k plus k. So this is 3 minus 2k is equal to 0. We want this quadratic equation to have real roots. We know that if you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, the discriminant d of this quadratic equation is b square minus 4ac. Now if the discriminant is greater than or equal to 0, this quadratic equation will have two real roots. So here we want the discriminant of this quadratic equation to be greater than or equal to 0. What is the discriminant? The discriminant is square of the coefficient of x, which is 4 minus 4k whole square. We want this to be greater than or equal to 4 times the coefficient of x, which is x square, that is 3 minus 3k, into the constant term, which is 3 minus 2k. This is 16 times 1 minus k whole square has to be greater than or equal to 4 into 3 into 1 minus k into 3 minus 2k. You can cancel 1 4, this is 4. If you are bringing everything to the other side, this is 4 times k minus 1 whole square plus 3 times 1 minus k, when you bring it to the other side, becomes k minus 1 into 3 minus 2k. You want this to be greater than or equal to 0. So you take k minus 1 common. You have 4k minus 4 plus 9 minus 6k. You want this to be greater than or equal to 0. Or k minus 1, and this is 5 minus 2k has to be greater than or equal to 0. We'll multiply both sides with minus 1 because I want this to be 2k minus 5. So it is k minus 1 into 2k minus 5 is less than or equal to 0, or k has to belong to 1 comma 5 by 2. If you're looking at it, you will feel that k can be even equal to 1, but k cannot be equal to 1, because if k is equal to 1, this quadratic equation becomes equal to a minus a plus 1 is equal to 0, which is not true. So k cannot take the value of 1. So this will be k belonging to 1 comma 5 by 2. So the answer for this question is option B. In this question, we are asked to calculate the number of real solutions of the equation e to the power 4x plus 4 times e to the power 3x minus 58 e to the power 2x plus 4 times e to the power x plus 1 is equal to 0. If you assume that e to the power x is equal to y, the equation that we have is y to the power 4 plus 4 times y cube minus 58y square plus 4 times y plus 1 is equal to 0. If you're looking at this kind of a question, the first thing you will do is try to factorize it, that is, try to substitute y is equal to 1 and see if the equation becomes equal to 0. Then we can assume that y minus 1 is a factor of this given polynomial. But when y is equal to 0, this y is equal to 1, this is not equal to 0. Then try y is equal to 2. Even then this is not equal to 0. You try y is equal to minus 1. Even then this is not equal to 0. Now you are wondering, how do I proceed? Because I would want to factorize it to figure out how many solutions it has. Then you will figure out that, okay, the coefficient of y cube and y is the same. The coefficient of y to the power 4 and the constant term is the same. In this kind of a situation, if you divide the entire equation with y square, you are going to get y square plus 4y minus 58 plus 4 by y plus 1 by y square is equal to 0. Or if you combine this one and this one, you are going to get y square plus 1 by y square plus 4 times y plus 1 by y minus 58 is equal to 0. Now you will understand why I said the coefficients of y cube and y are the same. Because I would want to make y plus 1 by y to be a new variable. Similarly, I want to make y square plus 1 by y square. I want to express it in terms of y plus 1 by y. For that also, if the coefficient of y to the power 4 and the constant term are the same, it becomes easy. So for example, if you assume that y plus 1 by y is equal to a new variable, say p, if you are squaring this, y square plus 1 by y square plus 2 is equal to p square, or y square plus 1 by y square is equal to p square minus 2. So this equation is p square minus 2 plus 4p minus 58 is equal to 0. This is p square plus 4p minus 60 is equal to 0. This is p square plus 10p minus 6p minus 60 is equal to 0. This is p plus 10 into p minus 6 is equal to 0. So the value of p is either minus 10 or the value of p is equal to 6. What is p? P is y plus 1 by y. But what is y? Y is e to the power x. Y will always be greater than 0. Whatever may be the value of x, e to the power x is always greater than 0. So here, y plus 1 by y being equal to minus 10 doesn't make sense. E to the power x plus e to the power minus x is always positive. So y plus 1 by y can be equal to 6. If you are simplifying it, you are going to get y square minus 6y plus 1 is equal to 0, or y is equal to 6 plus or minus square root of 6 square, which is 36, minus 4 divided by 2. This is 3 plus or minus square root of 8, which is either 3 plus 2 root 2 or 3 minus 2 root 2. 3 plus 2 root 2 is positive, 3 minus 2 root 2 is positive. Both of them can be e to the power x. So the values that x can take are two values. One is log of 3 plus 2 root 2 to the base e. Another one is log of 3 minus 2 root 2 to the base e. These two are valid. So this has two solutions for the given equation. In this question, we are told that p and q are two numbers such that p plus q is 2 and p to the power 4 plus q to the power 4 is 272. Then p plus q are roots of the equation. If we are required to calculate the quadratic equation for which p and q are the roots, we need to calculate the sum of roots, which is p plus q, and the product of roots. What is the product of roots? The product of the roots is p into q. These are the things that we need to calculate. P plus q is already given to us. P plus q is 2. So if we can calculate the product of the roots, we can answer this question. So we need to calculate p into q. P plus q is equal to 2. So p plus q whole square is 2 square. P square plus q square plus 2pq is equal to 4. If you assume that the product of the roots p into q is, say, t, p square plus q square is 4 minus 2t. If you square it again, p to the power 4 plus q to the power 4 plus 2 times p square q square is 4 minus t whole square. But 2 times p square q square is 2 times t square, because p into q is equal to t. And p to the power 4 plus q to the power 4 is given to us, that is equal to 272. So 272 plus 2 times t square is equal to 16. This is 4 minus 2t whole square plus 4t square minus, this is 4 minus 2t, this is 4 minus 2t whole square. This is 4 into 2, which is 16t. If you are simplifying it, you are going to get 2t square minus 16t minus 256 is equal to 0. Or t square minus 8t minus 128 is equal to 0. This can be factorized to equal t minus 16 into t plus 8 is equal to 0, or the value of t is either equal to 16 or the value of t is equal to minus 8. That is, the product of p into q is either equal to 16 or the product p into q is equal to minus 8. We know the value of p plus q is equal to 2. Therefore, the quadratic equation can be either x square minus 2x plus 16 is equal to 0, or x square minus 2x minus 8 is equal to 0. It can be either one of these two. If you're looking at the options that are given, we don't have x square minus 2x minus 8. Therefore, the correct answer will be x square minus 2x plus 16 is equal to 0. In this question, we are asked to calculate the number of real solutions of the equation x square minus modulus of x minus 12 is equal to 0. Modulus of x is always non-negative, it is always greater than or equal to 0. So if you assume that modulus of x is equal to p, this given equation, because x square is equal to modulus of x whole square is equal to p square, this given equation will become equal to p square minus p minus 12 is equal to 0. This can be factorized to equal p square minus 4p plus 3p minus 12 is equal to 0. This is p minus 4 into p plus 3 is equal to 0. So either p is 4 or p is minus 3. But we know that p is the modulus of x, which is always greater than or equal to 0. Modulus of a number is never negative. So p cannot be equal to minus 3. So p is equal to 4, or modulus of x is equal to 4. So x is either 4 or x is minus 4. Therefore, the number of real solutions for this given equation will be equal to option A, which is 2.
మీ ఫోన్ ఆల్రెడీ జేఈ నుంచి చాలా డిస్ట్రాక్ట్ చేస్తుంది. నౌ లెట్ ఇట్ టేక్ యూ ఫ్రమ్ స్క్రోల్ టు స్కోర్. 10 minutes ఫ్రీ ఉందా? మీ డైలీ టార్గెట్ ఓపెన్ చేసి కొన్ని క్వశ్చన్ సాల్వ్ చేయండి. ఒక క్వశ్చన్ దగ్గర స్టక్ అయ్యారా? IITN ఫ్యాకల్టీ వీడియో సొల్యూషన్స్ చూసి నేర్చుకోండి. చాప్టర్ కంప్లీట్ అయిందా? 12,000 ప్లస్ JEE PYQs నుంచి ప్రాక్టీస్ చేయండి. డౌన్లోడ్ ది క్రాకో JEE యాప్ నౌ. మీ స్క్రీన్ టైమ్ని ప్రెప్ టైమ్గా మార్చండి.
In this question, we are told that p and q belong to real numbers. Consider the function f of x, which is x minus p whole square minus q. X belongs to real numbers and q is greater than 0. A1, A2, A3 and A4 are 4 numbers which are in an arithmetic progression with a mean equal to p and positive common difference. Now, modulus of f of ai is equal to 500 for all the 4 values of I, that is A1, A2, A3 and A4. The absolute difference between the roots of f of x is equal to 0 is. Now, if you think about it, f of x is a quadratic equation. So, f of x is equal to 500. How many roots will it have? It will have maximum of 2 roots. It will have maximum of 2 real roots. Now, how can A1, A2, A3 and A4, all 4 of them satisfy this equation? They will satisfy this equation only if 2 roots satisfy f of x is equal to 500 and 2 roots satisfy f of x is equal to minus 500. So if modulus of ai is equal to 500, modulus of ai is either 500, that will have 2 roots, and modulus of ai is equal to minus 500 will have 2 other roots. F of x is equal to 500, what does that imply? F of x is x minus p whole square minus q. So x minus p whole square minus q is equal to 500, or x minus p whole square is equal to q plus 500, or x minus p is either equal to square root of q plus 500 or it is minus of square root of q plus 500. So x is p plus square root of q plus 500. Another root is p minus square root of q plus 500. This is for f of x is equal to 500. What about f of x is equal to minus 500? If f of x is equal to minus 500, we will be having x minus p whole square minus q is equal to minus 500, or x minus p whole square is equal to q minus 500, or x minus p is either square root of q minus 500 or minus of square root of q minus 500. So x is equal to p plus square root of q minus 500 or p minus square root of q minus 500. So the four values are p plus square root of q plus 500, p minus square root of q plus 500, p plus square root of q minus 500, and p minus square root of q minus 500. These are the four values. One of this is a1, one of this is a2, one of this is a3, and one of this is a4. a1 is the smallest of these four. How do I know it? Because a1, a2, a3, and a4 are in an arithmetic progression with a positive common difference. So a1 is less than a2 is less than a3 is less than a4. Which of this is the highest? You will figure out that this will be the highest. So a4 is equal to p plus square root of q plus 500. Which of this is the smallest? Smallest is a1, and the smallest will be p minus square root of q minus q plus 500. The second smallest will be p plus square root of q minus 500. And a2 is p minus square root of q minus 500. Why did I write all of this? I wrote all of this because they are in an arithmetic progression. So the difference between these two numbers, if you assume is d, which is the common difference of the arithmetic progression, the difference between these two is also equal to d. The difference between these two is also equal to d. For example, what is a4 minus a1? a4 minus a1 is equal to 3d, or the value of 3d is equal to, you can cancel p and p, you will be getting 2 times square root of q plus 500. What is the difference between a3 and a2? The difference between a3 and a2 is the common difference d, and d will be equal to 2 times square root of q minus 500. Because if I am subtracting these two, p will get cancelled and I will be left with 2 times square root of q minus 500. Now if I divide this equation, one equation with the other, 3 is equal to square root of q plus 500 divided by q minus 500. Or if I square it, I'm going to get q plus 500 divided by q minus 500 is equal to 9. Or q plus 500 is equal to 9q minus 4500. Or 8q is equal to 5000. Or the value of q is 625. Now what am I required to calculate? What I'm required to calculate is the absolute difference between the roots of f of x is equal to 0. F of x is equal to 0 would be x minus p whole square minus q is equal to 0, or x minus p whole square is equal to q, or x minus p is equal to either square root of q or minus square root of q. So x is either p plus square root of q, this is one root, The other root is p minus square root of q. Q is 625. So this will be p plus 25 or p minus 25. And what is the difference between these two? The difference between these two is 50. So the answer for this particular question is equal to 50. In this question, we are asked to calculate the sum of all the real values of x, for which 3x square minus 9x plus 17 divided by x square plus x plus 10 is equal to 5x square minus 7x plus 19 divided by 3x square plus 5x plus 12. If you are looking at it, if you are trying to find some sort of a pattern, it is difficult to find any sort of a pattern, because one way to proceed further is, if you are looking at the numerator and denominator, we might try to take 3 outside this, because we have 3x square and we have x square. But over here, it will be 5 by 3. If you're looking at the coefficients of x square, it is 5 here and 3 here. So there is no common thing. Similarly, even if you're looking at any particular term, we have 3x square minus 9x here. We have x square plus 3x here. We have 5x square minus 7x here. 3x square plus 5x. So there is nothing which is common. So in this kind of question, what I would normally do is, I would cross multiply first, because I'll bring all the terms to one side and then I'll try to find some sort of a pattern. If I'm cross multiplying, I'm going to get 3x square minus 9x plus 17 into 3x square plus 5x plus 12, this is the left hand side, is equal to 5x square minus 7x plus 19 into x square plus 3x plus 10. This is the equation after we cross multiply. Now if you notice closely, the sum of these two expressions and the sum of these two expressions are the same. What is the sum of 3x square minus 9x plus 17 and 3x square plus 5x plus 12? The sum will be 6x square minus 4x plus 29. What is the sum of these two? 5x square minus 7x plus 19 and x square plus 3x plus 10. That will be 6x square minus 4x plus 29. These two are the same. So now we can find some sort of a pattern. We can make it easier. We'll assume that this is equal to A, this expression. We'll assume that this expression is equal to B and this expression is equal to C. Now what is the value of A plus B? A plus B is 6x square minus 4x plus 29. What is the value of this plus C? It is again equal to 6x square minus 4x plus 29. Or the value of this expression will be A plus B minus C. Or what I have is A into B is equal to A plus B minus C into C. Or A into B is AC plus BC minus C square. Or I have AB minus AC is equal to BC minus C square. Or A into B minus C is equal to C into B minus C. Or A minus C into B minus C is equal to 0. So that quadratic equation can be simplified to equal A minus C. What is A minus C? That is 3x square minus 9x plus 17 minus x square plus 3x plus 10. A minus C will be 2x square minus 12x plus 7. This is the value of A minus C. What is B minus C? This is B minus C is 2x square plus 2x plus 12. The product of both of them is equal to 0. That is 2x square minus 12x plus 7. This is A minus C into 2x square plus 2x plus 2. This is equal to 0. This, if you simplify, is just x square plus x plus 1. I'm just dividing this quadratic equation by 2. This has no real roots. X square plus x plus 1, the discriminant of this quadratic equation is greater than 0. Another way to look at it is x square plus x plus 1 is x plus 1 by 2 whole square plus 3 by 4. This is always greater than 0. So this has no real roots. This, on the other hand, will have two real roots, because here the discriminant actually is, discriminant is less than 0. Here the discriminant is greater than 0. What is the discriminant? It is 12 square, which is 144, minus 4 into 2 into 7. This comes to equal 56. 144 minus 56 is greater than 0. So this will have two real roots. And what is the sum of both the roots? The sum of both the roots will be 12 divided by 2, which is equal to 6. Because we know that if you have a quadratic equation of the form ax square plus bx plus c is equal to 0, sum of roots is minus b by a. So in this particular case, that will be minus of minus 12 divided by 2, which is equal to 6. So the sum of all the real roots of this given quadratic equation is 6. In this question, we are asked to calculate the number of distinct real roots of the equation x to the power 5 into x cube minus x square minus x plus 1 plus x into 3x cube minus 4x square minus 2x plus 4 minus 1. So if you are looking to expand this, we are going to get x to the power 8 minus x to the power 7 minus x to the power 6 plus x to the power 5 plus 3x to the power 4 minus 4x cube minus 2x square plus 4x minus 1 is equal to 0. If you substitute the value of x to be equal to 1, this will be 1 minus 1 minus 1 plus 1 plus 3 minus 4 minus 2 plus 4 minus 1. All of this cancel each other. These 4 will sum up to 0. Minus 4 plus 4 sums up to 0. 3 minus 2 minus 1 is equal to 0. This would imply that x minus 1 is a factor of this polynomial. So let us try to factorize it and take x minus 1 common. What are you going to get? From these two terms, you are going to get this is x to the power 7 into x minus 1. Plus from these two terms, it is minus x to the power 5 into x minus 1. From these two terms, we can express this as 3x to the power 4 minus 3x cube minus x cube plus x square minus 3x square plus 3x plus x minus 1. This expression is same as this expression. I've just expanded it in such a way that every pair I can take x minus 1 common. For example, from these two I can take plus 3x cube into x minus 1, and from these two I can take minus x square into x minus 1. From these two I can take minus 3x into x minus 1, and from these two I can take plus 1 into x minus 1 is equal to 0. Now I can take x minus 1 common, and I will be left with x minus 1 into x to the power 7 minus x to the power 5 plus 3x cube minus x square minus 3x plus 1 is equal to 0. So clearly x minus 1 is a factor of the given polynomial. If you are looking at this polynomial, from these two I can take x square minus 1 common. From this one and this one I can take x square minus 1 common. From this one and this one I can take x square minus 1 common. So overall the entire expression will become equal to, this is x minus 1 into this is x to the power 5 into x square minus 1 plus 3x into x square minus 1 minus 1 into x square minus 1 is equal to 0. Now I can take x minus 1 common, and I can take x square minus 1 common. This will be x to the power 5 plus 3x minus 1 is equal to 0. This is the given expression. So one of the roots is x is equal to 1, because x minus 1 can be 0, x is equal to 1 is a root. For x square minus 1, x can be plus or minus 1. So again, the two roots from these three equations are x is equal to 1 or minus 1. What about the third term? How many roots does x to the power 5 plus 3x minus 1 is equal to 0 have? First, let us see if x is equal to 1 is a factor. If you substitute x is equal to 1, we are going to get 1 plus 3 minus 1, which is 3. So x is equal to 1 is not a factor. What about x is equal to minus 1? This will be minus 1, minus 3, minus 5. So again, x is not equal to minus 1. Now if you're looking at it, if you're calling this f of x, what is the derivative of f of x? If you differentiate this equation with respect to x, you are going to get 5x to the power 4 plus 3. Now 5x to the power 4 plus 3 is strictly greater than 0. Because x to the power 4 is greater than 0, 3 is a positive number, 5 times x to the power 4 plus 3 is greater than 0. So differential of f of x is always greater than 0. This would imply that f of x is a monotonously increasing function. What does this mean? If you have y-axis and if you have x-axis, as x continues to increase, the value of the function also continues to increase. So there will be one point at which it will touch the x-axis. For example, this function, when x is say minus 100, f of x is less than 0. When x is equal to plus 100, f of x is greater than 0. So at some point it is less than 0, at some point it is greater than 0, at some point it is going to touch the x-axis. It is at that point that we will have a root for f of x, and that root is not 1 or minus 1. So overall, the total number of roots of this given equation will be 3. What are those 3? 1, minus 1, and the root of the function x to the power 5 plus 3x minus 1. So it will have 3 roots. And therefore, the answer for this particular question is 3. In this question, we are asked to calculate the number of real roots of the equation x plus 1 whole square plus modulus of x minus 5 is equal to 27 by 4. This equation has a modulus x minus 5, modulus of it. So we'll consider two cases. In the first case, x is less than or equal to 5. And in the second case, x is greater than 5. If x is less than or equal to 5, modulus of x minus 5 is 5 minus x. So the given equation becomes equal to x plus 1 whole square, which is x square plus 2x plus 1 plus modulus of x minus 5, which is 5 minus x, is equal to 27 by 4. This is x square plus x is equal to 7 by 4. This is not 7 by 4, this is 6, so 3 by 4. Or 4x square plus 4x minus 3 is equal to 0. This is 4x square plus 6x minus 2x minus 3 is equal to 0. This is 2x minus 1 into 2x plus 3 is equal to 0. So the value of x is 1 by 2 or the value of x is minus 3 by 2. These are two values and both of them are actually less than or equal to 5. So both of these are valid solutions. In this case, we have two solutions. What about the case where x is greater than 5? If x is greater than 5, modulus of x minus 5 is equal to x minus 5. So the given equation becomes equal to x square plus 2x plus 1 plus x minus 5 is equal to 27 by 4. This is x square plus 3x. This is minus 4. If you take it there, it becomes 43 by 4. Or 4x square plus 12x minus 43 is equal to 0. If you are just using this, the value of x will be again just x square plus 3x, because you can't simplify it easily. This is 4x square plus 12x minus 43. So this is x square plus 3x minus 43 by 4 is equal to 0. So the value of x is minus 3 plus or minus square root of b square. So this is 9 minus of minus 43 by 4 into 4. So this is plus 43 divided by 2. So one value is minus 3 minus square root of 52 by 2. Another value is minus 3 plus square root of 52 by 2. And we want the value of x to be greater than 5. This is a negative number, so this is invalid. This is what is the approximate value of square root of 52. 49 is 7 square. 64 is 8 square. So this is close to, say, minus 3 plus 7.2 by 2. This is approximately 2.1. But we want this number to be greater than 5. So this also is not valid. So in this particular case, we'll have 0 solutions. So the final number of solutions for this given equation will be 2. And therefore the answer for this question is 2. In this question, we are asked to calculate the sum of all the roots of the equation e to the power 2x minus 11 times e to the power x minus 45 times e to the power minus x plus 81 by 2 is equal to 0. So this equation, if you are, because you have a e to the power 2x, e to the power x and a term which contains e to the power minus x, if you multiply this entire equation with e to the power x, the equation we have will be e to the power 3x minus 11 times e to the power 2x plus 81 by 2 into e to the power x minus 45 is equal to 0. Now this is a term which is basically cube of e to the power x. For this, we will be having some roots. We have to calculate the sum of all the roots. Because this is a cubic equation in e to the power x, this will have 3 roots. So what we are required to calculate is, if the 3 roots are x1, x2 and x3, we are required to calculate x1 plus x2 plus x3. What is the value of this? This is what we are required to calculate, the sum of the roots of this equation. Let us assume that e to the power x is equal to p. Then this equation becomes equal to p cube minus 11p square plus 81 by 2 p minus 45 is equal to 0. Now this equation will have 3 roots. What are the 3 roots? The 3 roots will be e to the power x1, e to the power x2 and e to the power x3. These are the 3 roots of this given cubic equation, because we assume that e to the power x is equal to p. What is the product of the roots? The product of the 3 roots is equal to 45. That is, 45 is equal to e to the power x1 into e to the power x2 into e to the power x3. Or this is equal to e to the power x1 plus x2 plus x3 is equal to 45. That is minus of the constant term. Or the sum of x1 plus x2 plus x3 is equal to ln of 45. That is log of 45 to the base e. This is the value of x1 plus x2 plus x3, which is what we are required to calculate. So the answer for this particular question is, because this is log p to the base e, log p to the base e is log of 45 to the base e. So the value of p will be equal to 45. In this question, we are told that p and q are real numbers such that p plus q is 3 and p to the power 4 plus q to the power 4 is 369. We are required to calculate the value of 1 by p plus 1 by q to the power minus 2. So if you're looking at what we have to actually calculate, we have to calculate 1 by p plus 1 by q to the power minus 2, which is equal to p plus q divided by p into q to the power minus 2, which is simply equal to pq whole square divided by p plus q whole square. We are already given the value of p plus q. P plus q is equal to 3. So what we are essentially required to calculate is pq whole square divided by 9. If you are able to calculate the value of p into q, we can answer this question very easily. Looking at the two things that we are given, p plus q is equal to 3 and p to the power 4 plus q to the power 4 is equal to 369. If you square this equation, you are going to get p square plus q square plus 2 times pq is equal to 9. Or p square plus q square is equal to 9 minus 2pq. We plan to square this again p square plus q square, because then we'll get a term which involves p to the power 4 plus q to the power 4. Also, what we are required to calculate is p into q. Considering all of this, let us assume that p into q is equal to a new variable called k. So this basically tells us that p square plus q square is equal to 9 minus 2k. If you square this equation, you are going to get p to the power 4 plus q to the power 4 plus 2 times p square q square is equal to 9 minus 2k whole square. But again, p square q square, because we assume that p into q is k, p square q square will be k square. And p to the power 4 plus q to the power 4 is 369. So we have 369 plus 2k square is equal to 9 minus 2k whole square, which is 81, minus 2 into 9 into 2k, which is 36k, plus 4k square. Or the equation we have is 4k square minus 2k square will be 2k square minus 36k minus 288 is equal to 0. We can divide this equation with 2. We are left with k square minus 18k minus 144 is equal to 0. This is k plus 6 into k minus 24 is equal to 0. So PQ, which is the value of k, is either equal to minus 6 or PQ is equal to 24. We have P plus Q is equal to 3. If P plus Q is equal to 3 and P into Q is equal to 24, this one and this one would imply that both P and Q are positive. If the product of two numbers is positive, either both of them are positive or both of them are negative. If both of them are negative, their sum will not be positive. So the only implication is that if PQ is 24 and P plus Q is equal to 3, both P and Q are greater than 0. If P and Q are both greater than 0, using the arithmetic mean is greater than or equal to geometric mean, the maximum value of PQ can be calculated because P plus Q by 2 is greater than or equal to square root of PQ. P plus Q by 2 is 3 by 2 is greater than or equal to square root of PQ, or PQ will be less than or equal to 9 by 4. So there is no way P into Q is equal to 24, then P and Q will not be real numbers. Now if PQ is equal to minus 6, if the product of two numbers is equal to minus 6, one of them is positive and one of them is negative. When one of them is positive and one of them is negative, we can't apply the arithmetic mean is greater than or equal to geometric mean. In this particular case, P plus Q can be 3 and P into Q can be minus 6. For example, I'll give you an example. We can assume that P is equal to say 6.5 and Q is equal to say minus 3.5. This is actually much higher. We can actually make it even lesser. Say if P is equal to, I think, say 4.2 and Q is equal to minus 1.2. Roughly, if you calculate it, their product will be close to minus 6. You can make it even higher. You can make P to be 5 and Q to be minus 2. Then the product will be minus 10. Or you can make it lesser. You can make P to be 4 and Q to be minus 1. Then their product is minus 4. So the product can continue to vary quite a lot because one of them is positive and one of them is negative, and you cannot apply the arithmetic mean is greater than or equal to geometric mean. This formula you can only apply if both of them are positive. So the only case is that P into Q is equal to minus 6. What are we required to calculate? We are required to calculate PQ square divided by 9, which will be 6 into 6, 36 divided by 9, which is equal to 4. So the answer for this particular question will be 4. In this question, we are told that A and B belong to real numbers such that the equation ax square minus 2bx plus 15 has a repeated root alpha. When a quadratic equation has a repeated root, it would imply that the discriminant is equal to 0. We know that if you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, the discriminant is b square minus 4ac. If the discriminant is greater than 0, we have two real roots. If the discriminant d is equal to 0, we have one real root, or basically the root is repeated. If d is less than 0, we have complex roots. This is the case that we are being referred to, that we have a repeated root, so the discriminant is equal to 0. What is the discriminant of this given quadratic equation? It is the coefficient of x whole square, which is 4b square, minus 4 times the coefficient of x square, which is a, into the constant term. This is equal to 0, or b square is equal to 15a, or the value of a is equal to b square by 15. And what is the repeated root? The repeated root, if this equation has a repeated root, the repeated root will be minus b by 2a. So in this particular case, what is the value of alpha? Alpha will be equal to 2b divided by 2a, which is equal to b by a. This is the value of the repeated root. We know that a is b square by 15. So b by a, which is the value of alpha, will be b divided by b square by 15, which is equal to 15 by b. This is the value of the repeated root, which is alpha. Now alpha and beta are the roots of the equation x square minus 2bx plus 21. X square minus 2bx plus 21 is equal to 0, has two roots, alpha and beta. Again, if you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, what is the sum of roots? Sum of roots is equal to minus b by a. And what is product of roots? Product of roots is c by a. In this particular case, the two roots are alpha and beta. So alpha plus beta is equal to 2b, and alpha into beta is equal to 21. Alpha is 15 by b. So 15 by b into beta is equal to 21. This is 5, this is 7, or the value of beta is equal to 7b by 5. Now alpha plus beta is 2b. So 15 by b, which is alpha, plus 7b by 5, which is beta, is equal to 2b, or 15 by b is equal to 3b by 5, or the value of b square is equal to 25. This is 5. B is plus or minus 5. What are we required to calculate? We are required to calculate alpha square plus beta square. This is alpha, so alpha square is 15 by b whole square, which is 225 by b square. What is beta square? Beta is 7b by 5, so beta square is 49 b square by 25. B square is 25, so alpha square is 225 by 25, which is 9, and beta square is 49 into 25 by 25, which is 49. And the sum of both of them will be 9 plus 49, which is 58. So the answer for this particular question is option B, which is 58. In this question, we are asked to calculate the sum of all the real roots of the equation e to the power 2x minus 4 into 6e to the power 2x minus 5e to the power x plus 1 is equal to 0. If you assume that e to the power x is a variable, say y, e to the power 2x is y square. So the equation that we have is y square minus 4 into 6y square minus 5y plus 1 is equal to 0. We can factorize this as 6y square minus 5y plus 1 is equal to 6y square minus 3y minus 2y plus 1, which is 3y minus 1 into 2y minus 1. So the given equation is y square minus 4, which is y minus 2 into y plus 2 into 3y minus 1 into 2y minus 1 is equal to 0. So the value of y is either 2 or y is minus 2, or y is 1 by 3 or y is 1 by 2. What is y? Y is e to the power x. So e to the power x is either 2 or e to the power x is minus 2 or e to the power x is 1 by 3 or e to the power x is 1 by 2. Now e to the power x cannot be a negative number, so we can cancel this. So x is either log 2 to the base e or log 1 by 3 to the base e or log 1 by 2 to the base e. And the sum of all the solutions will be log of to the base e 2 into 1 by 3 into 1 by 2, which is equal to log of 1 by 3 to the base e, which is minus of log 3 to the base e, which is minus ln of 3, which is option B. In this question, we are told that the sum of the squares of the reciprocals of the roots of alpha and beta of the equation 3x square plus lambda x minus 1 is equal to 0 is 15. And we are required to calculate 6 times alpha cube plus beta cube whole square is equal to what? If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, the sum of roots is equal to minus b by a, and the product of roots is equal to c by a. In this question, alpha and beta are the roots of 3x square plus lambda x minus 1 is equal to 0. So alpha plus beta is equal to minus lambda by 3, and alpha into beta is equal to minus 1 by 3. We are given that the sum of the squares of the reciprocals is 15. That is, we are told that 1 by alpha square plus 1 by beta square is equal to 15, or alpha square plus beta square divided by alpha square beta square is equal to 15, or alpha square plus beta square is equal to 15 alpha square beta square. We have the information about alpha plus beta and we have the information about alpha into beta. So we'll write this as alpha plus beta whole square minus 2 alpha beta is equal to 15 alpha square beta square. What is alpha plus beta? Is minus lambda by 3. So the square is lambda square by 9. Alpha beta is minus 1 by 3. So minus 2 alpha beta will be plus 2 by 3 is equal to 15 into alpha beta is again minus 1 by 3, square is 1 by 9. So you multiply the entire equation with 9, you are going to get lambda square plus 6 is equal to 15, or lambda square is equal to 9. So basically lambda is equal to plus or minus 3. What are we required to calculate? We are required to calculate 6 times alpha cube plus beta cube whole square. What is alpha cube plus beta cube? Alpha cube plus beta cube is alpha plus beta into alpha square minus alpha beta plus beta square. This is alpha plus beta into the second bracket, we can write it in terms of alpha plus beta whole square. This will be alpha plus beta whole square minus 3 alpha beta. What is the value of alpha plus beta? Alpha plus beta is minus lambda by 3. So this is minus lambda by 3 into alpha plus beta whole square, which is lambda square by 9, minus 3 alpha beta. Alpha beta is minus 1 by 3, 3 alpha beta is minus 1, minus of minus 1 is plus 1. Now we know that lambda square is 9 because lambda is plus or minus 3. So this is equal to 1. So essentially we have this as minus lambda by 3 into 2. This is the value of alpha cube plus beta cube. What we are required to calculate is 6 times alpha cube plus beta cube whole square. That will be equal to 6 times lambda square into 4 by 9. Again, we know that lambda square is 9, so you can cancel these two, and the required answer will be 24. So the answer for this particular question will be option C, which is 24. In this question, it is mentioned that lambda belongs to real numbers and the equation modulus of x square minus 2 times modulus of x plus modulus of lambda minus 3 is equal to 0. Then the largest element in the set x plus lambda, where x is an integer solution of this given equation, is asked. Now this is an equation. To simplify it, let us assume that modulus of x is equal to p. So p is a number which is greater than or equal to 0 because modulus of any number is greater than or equal to 0. So the equation looks something like p square minus 2p plus lambda minus 3 is equal to 0. What is the discriminant of this given equation? The discriminant is, for any quadratic equation of the form ax square plus bx plus c is equal to 0, the discriminant is b square minus 4ac. For this equation to have real roots, the discriminant has to be greater than or equal to 0. Here, the discriminant of this given equation is 2 square, that is 4, minus 4 times lambda minus 3. This has to be greater than or equal to 0. Or modulus of lambda minus 3 has to be less than or equal to 1. Now, if you are looking at this given equation, if x is an integer, modulus of x will also be an integer. So p is an integer, 2p is an integer. So lambda minus 3 also has to be an integer. If lambda minus 3 is not an integer, this equation will not have integer solutions. Because this will be an integer, this will be an integer, and this will be not an integer. Now we are looking for lambda minus 3, which is an integer, which is less than or equal to 0. Modulus of lambda minus 3, and modulus is always non-negative. So now we will have two cases. Either modulus minus 3 is equal to 0 or modulus of lambda minus 3 is equal to 1. If modulus of lambda minus 3 is equal to 0, the given equation will be of the form p square minus 2p is equal to 0. This is the equation. Or p is equal to 0 or p is equal to 2. What is p? P is modulus of x. So either x is 0 or x is 2 or x is minus 2. And what is the value of lambda? If modulus of lambda minus 3 is equal to 0, lambda will be equal to 3. So what is the maximum value of x plus lambda? In this set, the maximum value of x plus lambda will be 5. That will happen when x is 2 and lambda anyways is equal to 3. In the second case, where modulus of lambda minus 3 is equal to 1, the equation becomes equal to p square minus 2p plus 1 is equal to 0, which is p minus 1 whole square is equal to 0. This would imply that p is equal to 1. What is p? P is modulus of x. So x is either 1 or x is equal to minus 1. And if lambda minus 3 modulus of it is 1, lambda minus 3 is either 1 or lambda minus 3 is minus 1. That is, lambda will be equal to 4 or lambda is equal to 2. If you are trying to maximize the value of x plus lambda, it will be this plus this, and x plus lambda, the maximum value will be equal to 5. So the maximum value of x plus lambda in this case is 5, in this case is 5. So the answer for this question is 5.
సమ్టైమ్స్ కాన్సెప్ట్ మీకు తెలుసు బట్ క్వశ్చన్ చూస్తే సాల్వ్ అవ్వదు. అప్పుడు మీకు కొంచెం ఎక్స్ట్రా కావాలి. క్వశ్చన్ చూడడానికి ఒక ఎక్స్ట్రా పర్స్పెక్టివ్, మీరు రిపీటెడ్గా మిస్టేక్స్ చేస్తున్న టాపిక్స్లో ఎక్స్ట్రా ప్రాక్టీస్, కాన్సెప్ట్ చదివిన తర్వాత కూడా స్టక్ అయితే ఎక్స్ట్రా క్లారిటీ. అండ్ ఆ ఎక్స్ట్రా పర్స్పెక్టివ్ని ఎవరు బెటర్గా ఇవ్వగలరు? JEE AIR 29తో IIT బాంబే CSE క్రాక్ చేసిన మారుతి సార్ అలాంగ్ విత్ 15+ years నుంచి స్టూడెంట్స్కి మ్యాథ్ టీచ్ చేస్తున్న రాధాకృష్ణ సార్. క్రాకు JEE Maths కోర్స్ ఇస్ డిజైన్ బై మారుతి సార్ అండ్ టాట్ బై రాధాకృష్ణ సార్. టఫ్ క్వశ్చన్ని ఎలా చూడాలి, ఎక్కడ స్టార్ట్ చేయాలి, అప్రోచ్ని ఎలా బిల్డ్ చేయాలి, అవి నేర్చుకోండి. క్రాకు JEE Maths కోర్స్ మీ ప్రిపరేషన్కి ఒక లిటిల్ ఎక్స్ట్రా పుష్. లింక్ ఇన్ ద డిస్క్రిప్షన్.
In this question, we are told that alpha and beta are the two roots of the equation x square minus root 2x minus root 3 is equal to 0. And p of n is alpha to the power n minus beta to the power n, where n is a natural number. We are given an equation. We are told that 11 root 3 minus 10 root 2 into p10 plus 11 root 2 plus 10 into p11 minus 11 into p12 is equal to what? In this kind of equation, the first thing you have to notice is we have p10, p11 and p12, that is p's which are close to each other. Second, we have root 3 into P10, root 2 into P11, something like this. So let us first try to understand what is the information that is given. The information that is given is that alpha and beta are roots of this given equation. So alpha square minus root 2 alpha minus root 3 is equal to 0. This is the first thing that we need to know. Second, if you're looking at the equation that is given, like I mentioned, we have P10 into 11 root 3, P10 into 10 root 2, P11 into 11 root 2 and all. So one of the things that we should try to understand is we should try to get a equation between Pn plus 2, Pn plus 1 and Pn, because we have P10, P11 and P12. What I mean by that is this is one equation that we have. Similarly, beta square minus root 2 beta minus root 3 is equal to 0. If you are subtracting one equation from the other, you are going to get alpha square minus beta square is equal to root 2 into alpha minus beta plus 0, because root 3 will get cancelled. So one thing you will immediately notice is that, okay, P square or P2 is equal to root 2 into P1. This is one information that you have. Now going forward, you can actually multiply the first equation with alpha to the power n. If you are multiplying the first equation with alpha to the power n, you are going to get alpha to the power n plus 2 is equal to root 2 into alpha to the power n plus 1 plus root 3 to the power alpha to the power n. This is the same equation. I multiplied it with alpha to the power n. Similarly, this equation, if I multiply it with beta to the power n, I am going to get beta to the power n plus 2 is equal to root 2 into beta to the power n plus 1 plus root 3 into beta to the power n. Now again, if I subtract one equation from the other, the left hand side will be alpha to the power n plus 2 minus beta to the power n plus 2, which is p of n plus 2. This is equal to root 2 into p of n plus 1 plus root 3 into p of n. This is an equation that we are getting. Now if you are looking at the equation that you have, this also has P10, P11 and P12. So let us look at the given equation. We have 11 root 3 into P10 minus 10 root 2 into P10. This is the first term. I just expanded it. The second term is 11 root 2 into P11 plus 10 into P11. The third equation is minus 11 P12. This is the expression that we need to calculate the answer for. Using this equation, if you are substituting the value of n to be 10, P of 12 is equal to root 2 into P of 11 plus root 3 into P of 10. It is the same equation. I just substitute the value of n to be equal to 10. Now if you're looking at it, this is 11 root 3 into P10 plus 11 root 2 into P11 minus 11 into P12. So if I'm substituting or multiplying this equation with 11, I'm going to get 11 times P12 is 11 root 2 into P11 plus 11 root 3 into P10. Or these will be equal to 0. These two will add up to this. What we are essentially left with is just these two, which is 10 P11 minus 10 root 2 P10. So again, if I substitute the same equation, but here I'm going to put n is equal to 9. If I put n is equal to 9, what am I going to get? I'm going to get P of 11 is equal to root 2 into P of 10 plus root 3 into P of 9. And if I'm multiplying this equation with 10, 10 times P11 is equal to 10 root 2 P10 plus 10 root 3 P9. Or if I'm taking this to the other side, 10 times P11 minus 10 root 2 into P10 is equal to 10 root 3 into P9. Or this will add up to equal 10 root 3 into P of 9. So the answer for this particular question is option A. The key to solving these kind of questions is first looking at P10, P11 and P12. One way to go about it, which will be a lengthy way, is first calculate what is P10, then calculate what is P11 and P12, or trying to get a expression or a relationship between Pn plus 2, Pn plus 1 and Pn. Once you get this kind of an expression, solving it becomes easy because you can figure out that root 3 would have to be Pn, root 2 will have to be Pn plus 1, and the normal term will have to be Pn plus 2. That you will figure it out if you are able to get this equation. In this question, we are told that alpha and beta are the roots of the equation x square plus 2 root x minus 1 is equal to 0. We are required to calculate the quadratic equation whose roots are alpha to the power 4 plus beta to the power 4 and 1 by 10 into alpha to the power 6 plus beta to the power 6. If you are given a quadratic equation which is of the form ax square plus bx plus c is equal to 0, the sum of the roots of this quadratic equation is minus b by a, and the product of the roots of this quadratic equation is c by a. If the two roots of this given quadratic equation are alpha and beta, what is the value of alpha plus beta? Alpha plus beta will be minus 2 root 2. And what is the value of alpha into beta? Alpha into beta is minus 1. If you are squaring the first equation, alpha plus beta whole square is equal to minus 2 root 2 whole square, which is 8. That is alpha square plus beta square plus 2 times alpha beta is equal to 8. But alpha into beta is minus 1. So alpha square plus beta square minus 2 is equal to 8, or alpha square plus beta square is equal to 10. This is one equation. If you are squaring this equation again, alpha square plus beta square whole square is equal to 10 square, which is 100. That is alpha to the power 4 plus beta to the power 4 plus 2 alpha square beta square into alpha square is equal to 100. Alpha into beta is equal to 1. So alpha square into beta square is equal to 1. Alpha beta is minus 1. So the square of it will be 1. So alpha to the power 4 plus beta to the power 4 is equal to 98. This is one of the roots. For the second root, we need to calculate the value of alpha to the power 6 plus beta to the power 6. So we'll cube this equation. If you are cubing this equation, alpha square plus beta square whole cube is equal to 10 cube, which is 1000. Alpha to the power 6 plus beta to the power 6 plus 3 times alpha square beta square into alpha square plus beta square is equal to 1000. Or alpha to the power 6 plus beta to the power 6 plus 3 times alpha square into beta square is 1. Alpha square plus beta square is 10 is equal to 1000. Or alpha to the power 6 plus beta to the power 6 is 970. And 1 by 10th of this is equal to 97. This is one root. This is one root. Therefore, the quadratic equation will be x minus 97 into x minus 98 is equal to 0, or that is x square minus 195x plus 9506 is equal to 0. This is the quadratic equation, which will be option C. In this question, we are asked to calculate the number of distinct real roots of the equation modulus of x plus 1 into modulus of x plus 3 minus 4 times modulus of x plus 2 plus 5 is equal to 0. The first term is basically modulus of x plus 1 into x plus 3, which is modulus of x square plus 4x plus 3. The second term is minus of 4 times modulus of x plus 2 plus 5 is equal to 0. This is the given equation. This will have three inflection points. One is when x is minus 1, one is when x is minus 3, and the last one is when x is minus 2. So we'll consider 4 cases. Because there are 3 inflection points, we'll consider 4 cases. The first one is when x is less than minus 3. The second one is when minus 3 is less than or equal to x is less than or equal to minus 2. Then when x is lying between minus 2 and minus 1. And finally when x is greater than minus 1. These are the cases we will be looking at. In the first case, when x is less than minus 3, this term will be positive. So it will be x square plus 4x plus 3, and the second one will be negative. Modulus of x plus 2, because x plus 2 will be negative, this will be plus 4x plus 8 plus 5 is equal to 0. This would imply that this is x square plus 8x plus 16 is equal to 0, or this is x plus 4 whole square is equal to 0, or x will be equal to minus 4. Minus 4 lies in this interval, so this is a valid root. In the second interval, between minus 3 and minus 2, x square plus 4x plus 3 will be negative. So this will be negative because x plus 3 will be positive and x minus 1 will be negative. So the product of these two will be negative. Anyway, this will be minus x square minus 4x minus 3, and x plus 2 also will be negative. So modulus of x plus 2 will be minus x minus 2. So this will be plus 4x plus 8 plus 5 is equal to 0. If you are simplifying it, you are going to get x square is equal to 10. So either x is square root of 10 or minus square root of 10. What is square root of 10? It is approximately 3.1. So approximately this is either minus 3.15 or 3.15. That is the value of square root of 10. Both of these don't lie within this interval. Both of these numbers don't lie between minus 2 and minus 3. So both of them are not valid. So here we have one valid root, which is x is equal to minus 4. Here we have no valid root. If x lies between minus 2 and minus 1, again x square plus 4x plus 3 is negative. So this will be minus x square minus 4x minus 3. X plus 2 will be positive. So this is minus 4x minus 8 plus 5 is equal to 0. If you are simplifying it, this is x square plus 8x plus 6 is equal to 0, or x is equal to minus 8 plus or minus square root of 8 square is 64 minus 24 by 2. This is minus 4 plus or minus square root of 10. So this is minus 4 plus square root of 10 or minus 4 minus square root of 10. Again, square root of 10 is approximately 3.15. So this is either approximately minus 0.85 or this is minus 7.15. Both of them again don't lie between minus 2 and minus 1. So both of them are not valid roots. This also will be 0 roots in this interval. Finally, if x is greater than minus 1, all of the terms will be positive. That is, x square plus 4x plus 3 is positive. So modulus of that will be x square plus 4x plus 3. X plus 2 will be positive. So modulus of that will be again x plus 2. So this is minus 4x minus 8 plus 5 is equal to 0. This would simply imply that x square is 0 or x is 0. X is equal to 0 lies in the interval which is x greater than or equal to minus 1. So this is a valid root. So we'll have one valid root in this interval which is x is 0, and we have one valid root in this interval which is x is minus 4. So the whole equation will have two distinct real roots. In this question, the sum of all the solutions of the equation 8 to the power 2x minus 16 times 8 to the power x plus 48 is equal to 0 is asked. So in these kind of questions, when you have 8 to the power x repeated multiple times, let us assume that 8 to the power x is a variable a. So 8 to the power 2x, which is equal to 8 to the power x whole square, will be equal to a square. So the given equation is a square minus 16a plus 48 is equal to 0. This is simply a quadratic equation in A. This is a square minus 12a minus 4a plus 48 is equal to 0. This is a minus 12 into a minus 4 is equal to 0. So the value of a is either equal to 4 or the value of a is equal to 12. What exactly is a? A is 8 to the power x. So 8 to the power x is equal to 4. So the value of x is log of 4 to the base 8. In this case, a is equal to 12. So 8 to the power x is equal to 12, or x is equal to log of 12 to the base 8. So what is the sum of both the roots of x? It is log 4 to the base 8 plus log of 12 to the base 8, which is log of 48 to the base 8. Because remember that log of a plus log of b is log of a into b. So 12 into 4 is 48. 48 is log of 8 into 6 to the base 8. So this is 1 plus log of 6 to the base 8. So the answer for this question is 1 plus log of 6 to the base 8. In this question, we are told that alpha and beta are the distinct roots of the equation x square minus t square minus 5t plus 6x plus 1 is equal to 0, where t belongs to real numbers. A of n is alpha to the power n plus beta to the power n. Then the minimum value of a 2023 plus a 2025 divided by a 2024 is needed. When you look at what is needed, we are basically asking for a 2023 plus a 2025 divided by a 2024. This is what is needed. Now, if you think about it, there is definitely a way in which we have to simplify this, because nobody is expecting us to calculate what is the value of alpha to the power 2023 plus beta to the power 2023 plus alpha to the power 2025 plus beta to the power 2025 divided by alpha to the power 2024 plus beta to the power 2024. There has to be a way in which this can be simplified. If you look at alpha and beta, we know that alpha plus beta is the sum of the roots of the quadratic equation, which is t square minus 5t plus 6, and alpha into beta is equal to 1. The product of the roots of this equation will be the constant term, which is 1, and the sum of the roots is t square minus 5t plus 6. So we will use the fact that alpha into beta is equal to 1 to simplify this. If alpha into beta is equal to 1, beta will be 1 by alpha. We'll substitute that over here. This will be alpha to the power 2023 plus 1 by alpha to the power 2023, which is beta to the power 2023, plus alpha to the power 2025 plus 1 by alpha to the power 2025 divided by alpha to the power 2024 plus 1 by alpha to the power 2024. If you multiply the numerator and denominator with alpha to the power 2025 and you divide this also with alpha to the power 2025, then we can multiply each term with alpha to the power 2025 and the fractions will get removed. So this will be alpha to the power 4048 plus alpha square plus alpha to the power 4050 plus 1 divided by alpha to the power 4049 plus alpha. Now, if you combine these two terms and if you combine these two terms, the numerator can be factorized. Alpha to the power 4048 plus 1 will be the first term and the last term. And the second and the third term, you can take alpha square common and it will be alpha to the power 4048 plus 1. This will be the sum of the middle two terms. These two terms can be simplified to equal alpha square into alpha to the power 4048 plus 1. And these two terms are just equal to alpha to the power 4048 plus 1. So the numerator is equal to alpha to the power 4048 plus 1 into alpha square plus 1. And the denominator is alpha into alpha to the power 4048 plus 1. We can cancel this, we can cancel this. So the given fraction is simply equal to alpha plus 1 by alpha. And again, we know that alpha into beta is 1. So whatever is given is simply equal to alpha plus beta. We are required to calculate the minimum value of alpha plus beta. Alpha plus beta is equal to t square minus 5t plus 6. What is the minimum value of t square minus 5t plus 6. We can complete a perfect square over here. We can write this as t square minus 2 into 5 by 2 into t plus 5 by 2 whole square minus 5 by 2 whole square plus 6. This is a perfect square. This is equal to t minus 5 by 2 whole square. 5 by 2 whole square is 25 by 4. 6 minus 25 by 4 is minus 1 by 4. So this is a perfect square minus 1 by 4. So the minimum value will be equal to minus 1 by 4. So the answer for this particular question is option B, which is minus 1 by 4. In this question, we are told that x comma y exists such that x square minus 2 to the power y is 2023, where x and y are natural numbers. We are required to calculate the sum of all the values of x plus y. If you are looking at the equation that is given, x square is equal to 2 to the power y plus 2023. Now, there is only one equation and there are two variables x and y, and this also seems like a different type of an equation. We have 2 to the power y. We have 2 to the power y, which is not like a perfect square or something we can factorize easily. So looking at it, there is no usual way to solve these kind of questions. So one of the things that you have to remember is, and even if you are looking at the thing that is actually asked, which is sum of all the values of x plus y, one of the things you should remember is that most likely the number of solutions for this given equation will be limited. Only then will this kind of a question be asked. So if you think from that perspective, what will be the value of x? This is definitely even because y is a natural number. Any power of y will be an even number, and this is an odd number. So if you're looking at x, x has to be odd. So x will be of the form 2 times x1 plus 1, or x square will be 2x1 plus 1 whole square, which is of the form 4x1 square plus 4x1 plus 1. Now this is the left hand side, and that is the right hand side. If you are looking at the left hand side, 4x1 square plus 4x1, this is a multiple of 4. Now 2 to the power y will be a multiple of 4 if y is greater than or equal to 2. So if you consider the first case where y is equal to 1 separately, all other values of y, 2 to the power y will be a multiple of 4. So you have x square is equal to 2 to the power y plus 2023. If you are considering if y is greater than or equal to 2, the left hand side will leave a remainder of 1 when divided by 4. We are considering the case where y is greater than or equal to 2. This will be a multiple of 4. And 2023 is 2020 plus 3. So this is 505 into 4, which is 2020 plus 3. Or the right hand side will be, the remainder will be 3 when divided by 4. What we are essentially saying is that the first thing you have to remember is x will be a odd number because the right hand side is an odd number. If x is an odd number, the square of x will leave a remainder of only 1 when divided by 4. Every odd number's perfect square will leave a remainder of 1 when divided by 4. On the right hand side, however, if y is greater than or equal to 2, this will be a multiple of 4 and this will leave a remainder of 3 when divided by 4. So there will be no solution for it. The only case we have to consider separately is y is equal to 1, because when y is 1, 2 to the power y is not a multiple of 4. And when y is 1, what is the value of x square? X square is 2 to the power 1 plus 2023. This is equal to 2025, or the value of x is 45. So x is 45 and y is 1 is the only solution for this given equation, and the value of x plus y, which is what we are required to calculate, will be 46. In this question, we are required to calculate the set of all the values of a for which the given quadratic equation has no real roots. That interval is given as alpha and beta, and for all the integers which lie within that interval, we are required to calculate the sum of the squares. So if you are first trying to figure out when does this quadratic equation have no real roots. If you have a quadratic equation like ax square plus bx plus c is equal to 0, let us first calculate the discriminant of this given quadratic equation, which is b square minus 4ac. When the discriminant is greater than 0, the quadratic equation will have two real roots. When the discriminant is equal to 0, the quadratic equation will have one real root. And if the discriminant is less than 0, it will have no real root. For this given quadratic equation to have no real roots, the discriminant of this given quadratic equation has to be less than 0. What is the discriminant? The discriminant is a minus 5 whole square minus 4 into the coefficient of x square is 2 into this will be 15 minus 3a. This has to be less than 0. Because the quadratic equation, you can write this as 2x square plus a minus 5 into x plus 15 minus 3a is equal to 0. This is the coefficient of x square, this is the coefficient of x, and this is the constant term. If you are simplifying this, this is a square minus 10a plus 25 minus 120 plus 24a has to be less than 0. This is a square plus 14a minus 95 is less than 0. This is a square plus 19a minus 5a minus 95 is less than 0. This is a plus 19 into a minus 5 is less than 0, or a belongs to minus 19 to 5. Now what are the integers within this interval? The integers are minus 18, minus 17, minus 16, minus 2, minus 1, 0, 1, 2, 3, and 4. So what is the squares of the integers? That will be 18 square, 17 square, 16 square, 2 square, 1 square, 0. This is 1, 4, 9, and 16. What is the sum of all the squares? The sum of these squares we can find out easily using the formula. We know the formula for the sum of the squares of natural numbers till n square. That is 1 square plus 2 square plus plus n square is given by the formula n into n plus 1 into 2n plus 1 divided by 6. Here the value of n is 18. So this will be 18 into 19 into 37 divided by 6 plus the sum of this will be 16 plus 9 plus 4 plus 1 is 30. This is 3. This is 37 into 3 is 111 into 19 plus 30. 111 into 19 is 2109. This is 2109 plus 30, which is 2139. So the answer for this particular question is option D, which is 2139. In this question, we are asked to calculate the number of solutions of the equation 9 divided by x minus 9 divided by square root of x plus 2 is 2 by x minus 7 by square root of x plus 3 is equal to 0. Clearly, we have square root of x in the denominator and x in the denominator. So one way in which we can make better sense of it, make it slightly more intuitive, is assume that 1 by square root of x is equal to y. So the value of 1 by x is equal to y square. Therefore, the given equation becomes equal to 9y square minus 9y plus 2 into 2 by x becomes 2y square minus 7y plus 3 is equal to 0. This is the equation that we have. We can factorize 9y square minus 9y plus 2. We can write this as 9y square minus 6y minus 3y plus 2 And 2y square minus 7y plus 3 also can be factorized. We can write it as 2y square minus 6y minus y plus 3 is equal to 0. This is 3y minus 1 into 3y minus 2, and this is 2y minus 1 into y minus 3 is equal to 0. Therefore, the value of y is 1 by 3, or y is 2 by 3, or y is 1 by 2, or y is 3. This is the value of y. But what is y? Y is just equal to 1 by square root of x. So the value of x, basically we are saying, is 1 by y square. That is the value of x. So x is 9 or 9 by 4 or 4 or 1 by 9. So the number of values that x can take is 4. There are 4 solutions for this given equation. In this question, we are asked to calculate the sum of the squares of all the roots of the equation x square plus 2 times x square plus modulus of 2x minus 3 minus 4. There is one modulus in this, and the inflection point for that modulus is x is equal to 3 by 2, which is equal to 1.5. This is where the modulus will change its sign. As there is one inflection point, there will be two cases that we have to consider. In the first case, x is less than or equal to 3 by 2. In the second case, x is greater than 3 by 2. If x is greater than 3 by 2, modulus of 2x minus 3 is equal to 2x minus 3. So this solution becomes equal to x square plus 2x minus 3 minus 4 is equal to 0. This is x square plus 2x minus 7 is equal to 0. So x is equal to minus 2 plus or minus square root of 2 square is 4 plus 28, which is 32 divided by 2. This is equal to minus 2 plus or minus 4 square root of 2 divided by 2. So it is either 2 square root of 2 minus 1 or minus 2 square root of 2 minus 1. These are the two cases that are possible. Here we are looking only for the values of x which is greater than 3 by 2. If square root of 2 is equal to 1.414, this will be approximately equal to 1.8, maybe 1.82. And this will be negative, this will be, I think, approximately minus 3.82. So this is not valid, only this is a solution in this particular interval. In the second case, where x is less than 3 by 2, modulus of 2x minus 3 becomes equal to 3 minus 2x. So the given equation becomes equal to x square plus 3 minus 2x minus 4 is equal to 0. This is x square minus 2x minus 1 is equal to 0. So x is equal to 2 plus or minus square root of 2 square plus 4. So this is square root of 8 divided by 2. This is 2 plus or minus square root of 2 root 2 by 2. So it is either root 2 plus 1 or 1 minus root 2. These are the two cases that are possible. Again, root 2 is approximately equal to 1.414, and so this will be approximately 2.414. This is root 2 plus 1 or minus 0.414. Here we are only looking for values of x which is less than 3 by 2. So it has to be 1 minus root 2. So this equation has two solutions. One is 1 minus root 2, other one is 2 root 2 minus 1. And we are asked to calculate the sum of the squares of both the roots. What is the square of this root? Square is 1 plus 2 minus 2 root 2. And the square of this one will be 8 plus 1 minus 4 root 2. The sum of the squares will be 3 plus 9, which is 12, minus 6 root 2, which is, if you are taking 6 common, 2 minus square root of 2. So the answer for this particular question is option A, 6 into 2 minus root 2. In this question, we are asked to calculate the number of real solutions of the equation x square plus 3x plus 2 is equal to minimum of modulus of x minus 3 and modulus of x plus 2. If you look at the right hand side, it is minimum of modulus of x minus 3 and modulus of x plus 2. So which of these is minimum and which of this is maximum? So when is modulus of x minus 3 less than modulus of x plus 2? Both of them are positive numbers, so we are required to calculate when a is less than b, if both of them are positive or at least non-negative, because that is the whole point of modulus. So if you square them, is less than x plus 2 whole square, this is when it will happen, or x square minus 6x plus 9 has to be less than x square plus 4x plus 4, or the value of 10x has to be greater than 5, or the value of x has to be greater than 0.5. So the inflection point over here is x is equal to 0.5. So we'll consider two cases. One is when x is less than 0.5, and the second case is when x is greater than or equal to 0.5. When x is less than 0.5, what is minimum of modulus of x minus 3 and modulus of x plus 2? Here we have noticed that if x is greater than 0.5, the minimum will be modulus of x minus 3. So when x is less than 0.5, the minimum will be modulus of x plus 2. Similarly, when x is greater than or equal to 0.5, which is what we have seen over here, the minimum will be modulus of x minus 3. So in the first case, the equation that we have will become equal to x square plus 3x plus 2 is equal to modulus of x plus 2. Again, because we have a modulus whose inflection point will be x is equal to minus 2, we have to consider two cases. The first case is when x is less than or equal to minus 2, and the second case is when minus 2 is less than x is less than 0.5. In the first interval, modulus of x plus 2 will be minus x minus 2. This is the value of modulus of x plus 2. In the second case, modulus of x plus 2 will become equal to x plus 2. So here the equation that we have of x square plus 3x plus 2 is equal to modulus of x plus 2 becomes equal to x square plus 3x plus 2 is equal to minus x minus 2, or x square plus 4x plus 4 is equal to 0, or x plus 2 whole square is equal to 0. This would imply that x is equal to minus 2, which fits in this particular interval, so this is a valid solution. If x is lying between minus 2 and 0.5, the original equation becomes equal to x square plus 3x plus 2 is equal to x plus 2, or x square plus 2x is equal to 0, which is x into x plus 2 is equal to 0, or the value of x is 0 or minus 2. We have already counted minus 2 over here, and minus 2, x will lie between minus 2 and 0.5 strictly, because minus 2 is in the other interval. So the only solution in this particular interval is x is equal to 0. Let us now compare the second equality, the second interval, where x is greater than or equal to 0.5. Then the equation will be x square plus 3x plus 2 is equal to modulus of x minus 3. Again, we have a modulus. The inflection point of this modulus is 3. So we'll consider two cases. Here, anyway, x is greater than or equal to 0.5. So x is greater than or equal to 0.5, but it is less than 3. This is the first interval. And in the second interval, x is greater than 3. If x is less than 3, modulus of x minus 3 will be 3 minus x. If x is greater than 3, modulus of x minus 3 is equal to x minus 3. So the equation in this interval will be x square plus 3x plus 2 is equal to 3 minus x, or x square plus 4x minus 1 is equal to 0, So the value of x is minus 4 plus or minus square root of 4 square is 16. Minus of minus 4, so this is plus 4 divided by 2, which is minus 4 plus or minus square root of 20 by 2, which is minus 2 plus or minus square root of 5. Here we want x to be between 3 and 0.5. One root is minus 2 minus root 5 is negative, so that can be discarded. The other root is minus 2 plus square root of 5. Square root of 5 will be approximately 2.2. So minus 2 plus 2.2 is approximately 0.2. This also does not fit in the interval because we want x to be greater than 0.5. If you are looking at the second interval, modulus of x minus 3 is x minus 3. So here it is x square plus 3x plus 2 is equal to x minus 3, or x square plus 2x plus 5 is equal to 0. X square plus 2x plus 1 is equal to x plus 1 whole square. This would basically imply that x plus 1 whole square plus 4 is equal to 0. This also will not happen because this is a perfect square which is always non-negative, plus 4, so that will be a positive number. So the only two roots are x is equal to 0 and x is equal to minus 2. So we'll have two solutions for this given equation. The correct answer is option C.
JEE AIR 29 and 15 plus years experience ఉన్న మ్యాథ్ టీచర్ కలిసి ఒక JEE మ్యాథ్స్ కోర్స్ డిజైన్ చేస్తే ఎలా ఉంటుంది? యూ గెట్ ద బెస్ట్ ఆఫ్ బోత్ సైడ్స్. JEE క్రాక్ చేయడానికి ఏం కావాలో తెలిసిన పర్సన్ అండ్ స్టూడెంట్స్ ఎక్కడ స్టక్ అవుతారో ఎగ్జాక్ట్లీ తెలిసిన టీచర్. సో ఇక్కడ మీరు జస్ట్ ఫార్ములాస్ నేర్చుకోరు, కాన్సెప్ట్ని అండర్స్టాండ్ చేసుకుంటారు, క్వశ్చన్ని ఎలా అప్రోచ్ చేయాలో నేర్చుకుంటారు, ప్రాక్టీస్ చేస్తారు అంటిల్ ఇట్ క్లిక్స్. అండ్ ఎగ్జామ్ లైక్ కండిషన్స్లో మిమ్మల్ని మీరు టెస్ట్ చేసుకుంటారు. 150 plus concept videos, 150 plus concept tests, 400 topic tests, 15 full-length mocks, designed by IIT JEE AIR 29 Maruti Sir and taught by Radhakrishna Sir with 15 plus years of teaching experience. Learn, practice, apply. Check out the Cracku JEE Maths course, link in the description.
In this question, we are required to calculate the product of all the rational roots of the equation x square minus 9x plus 11 whole square minus x minus 4 into x minus 5 is equal to 3. If you are looking at the second term of the left hand side, it is x minus 4 into x minus 5. This is simply equal to x square minus 9x plus 20. So the given expression is x square minus 9x plus 11 whole square minus x square minus 9x plus 20 is equal to 3. Now one way to look at it is, the first term contains x square minus 9x. The second term also contains x square minus 9x. So let us see if we can make x square minus 9x plus 11, which is basically the first term, to be equal to a new parameter, and let us call it a variable p. So x square minus 9x plus 20 will be equal to p plus 9. So the expression that is given to us is p square minus p plus 9 is equal to 3, or p square minus p minus 12 is equal to 0. This quadratic equation can be simplified to equal p minus 4 into p plus 3 is equal to 0. So the value of p is either equal to 4 or p is equal to minus 3. But what is p? P is x square minus 9x plus 11. So either x square minus 9x plus 11 is equal to 4, or x square minus 9x plus 11 is equal to minus 3. In the first case, x square minus 9x plus 7 is equal to 0. In this quadratic equation, what is the discriminant? If you have a quadratic equation like ax square plus bx plus c is equal to 0, discriminant is b square minus 4ac. For the roots to be a rational number, this discriminant has to be a perfect square. Only if it is a perfect square will the roots be rational. What is the discriminant of this given equation? It is b square, that is 81, minus 4 times 7, which is 28. This is 53. This is not a perfect square. So the two roots of this given quadratic equation will not be rational. What about this one? This is x square minus 9x plus 14 is equal to 0. This is x square minus 7x minus 2x plus 14 is equal to 0. This is simply equal to x minus 7 into x minus 2 is equal to 0. So the two roots of this given quadratic equation are that x is equal to 2 or x is equal to 7. Those are the two rational roots, and their product, which is what we are required to calculate, is option A, which is 14. In this question, we are asked to calculate the product of all the solutions of the equation e to the power 5 log x to the base e whole square plus 3 is equal to x to the power 8. We see that in this exponent we have log x to the base e. So let us first write down the equation that is given. This is e to the power 5 times log of x to the base e whole square plus 3 is equal to x to the power 8. If you are taking log to the base e on both sides, the left hand side, for example, is of the form e to the power p, where p is just log x to the base e whole square plus into 5 plus 3. If you are taking log to the base e for this particular term, we are going to get just p. And on the right hand side, because this is x to the power 8, if you are taking log to the base e, you are going to get 8 times log x to the base e. So, if you are taking log to the base e on both sides of the equation, the left hand side becomes equal to 5 log x to the base e whole square plus 3, and the right hand side becomes equal to 8 times log of x to the base e. If you assume that log of x to the base e is equal to a new variable, say a, the given equation is 5a square plus 3 is equal to 8a, or 5a square minus 8a plus 3 is equal to 0. This is 5a square minus 5a minus 3a plus 3 is equal to 0, or we can factorize this as 5a minus 3 into a minus 1 is equal to 0. So a is either equal to 3 by 5 or a is equal to 1. But what exactly is a? A is log of x to the base e. So log of x to the base e is either equal to 3 by 5 or log of x to the base e is equal to 1. So x is either equal to e to the power 3 by 5 or x is equal to e. And the product of both of them, both the roots, is e to the power 8 by 5. So the answer for this particular question will be option A, which is e to the power 8 by 5. In this question, we are given alpha and beta. They are the two roots of the quadratic equation. Lambda x square minus lambda plus 3x plus 3 is equal to 0. And 1 by alpha minus 1 by beta is equal to 1 by 3. We are required to calculate the sum of all the possible values of lambda. If you are given a quadratic equation like ax square plus bx plus c is equal to 0, if you are told that the two roots are alpha and beta, what is the sum of the roots? Sum of the roots alpha plus beta is minus b by a, and the product of the roots alpha into beta is c by a. This is what we know about quadratic equations. In this quadratic equation, the coefficient of x is minus lambda plus 3, the coefficient of x square is lambda. So alpha plus beta is equal to lambda plus 3 divided by lambda. And the product of the roots alpha into beta is the constant term divided by the coefficient of x square, which is 3 by lambda. From the given quadratic equation, this is what we can infer. What we are given in addition to it is that 1 by alpha minus 1 by beta is equal to 1 by 3. So if we are given that 1 by alpha minus 1 by beta is equal to 1 by 3, on the left hand side, you are going to get this as beta minus alpha divided by alpha beta is equal to 1 by 3. It is easy in a quadratic equation to actually, if you are getting the difference between the roots, in this particular case beta minus alpha, to square it. Because if you square it, you can express the difference between the roots as sum of the roots and product of the roots. What I mean by it is, from this particular case, if you are squaring it, you are going to get beta minus alpha whole square divided by alpha square beta square is equal to 1 by 9. But you can calculate the value of beta minus alpha whole square. Beta minus alpha whole square is equal to beta plus alpha whole square minus 4 alpha beta. And what is alpha plus beta whole square? This is lambda plus 3 whole square divided by lambda square minus 4 times 3 by lambda. So what we are essentially getting is, this particular equation simply says that lambda plus 3 whole square minus 12 lambda divided by lambda square whole divided by alpha square beta square. Alpha beta is 3 by lambda. So the square of it will be 9 by lambda square is equal to 1 by 9. In the numerator and denominator, we can cancel 1 by lambda square. So what we are going to get is lambda square. What is lambda plus 3 whole square? It is lambda square plus 6 lambda plus 9 minus 12 lambda divided by 9 is equal to 1 by 9. We can cancel both of them. And the final quadratic equation we have is lambda square minus 6 lambda plus 8 is equal to 0. This is lambda minus 4 into lambda minus 2 is equal to 0. So the values that lambda can take are either lambda is equal to 2 or lambda is equal to 4. These are the two values that lambda can take, and the sum of those two values is equal to 6. So the answer for this particular question is 6. The smallest positive integral value of a, for which the roots x to the power 4 minus a into x square plus 9 are real and distinct. So here, if you assume that x square is equal to p, what is the quadratic equation looking like? It is p square minus ap plus 9 is equal to 0. Now for this, for the roots to be real, we want the discriminant of this quadratic equation to be greater than or equal to 0. And what is the discriminant of this given quadratic equation? The discriminant is a square minus 36. So we want a square minus 36 to be greater than or equal to 0 for the roots to be real. But we also want the roots to be distinct. Remember what we discussed. If d is greater than 0, we will have two real roots. If d is equal to 0, we will have one real root. Or both the roots are basically equal to each other. So we will have one distinct real root. If d is less than 0, we will have no real roots. So here we want this particular case to happen. So d being greater than or equal to 0 will not suffice. D has to be strictly greater than 0. Because if d is equal to 0, the roots will be real, but they won't be distinct. They will be equal to each other. So a square has to be greater than 36 or a has to be greater than 6, because we are only looking for positive integral values of a. So the smallest value that a can take will be equal to option B, which is equal to 7. In this question, the number of distinct real solutions of the equation x into modulus of x plus 4 plus 3 times modulus of x plus 2 plus 10 is equal to 0 is given. There are two modulus in this, modulus of x plus 4 and modulus of x plus 2. So there will be two inflection points, which is minus 4 and minus 2. This is the points at which the modulus will become equal to 0. As there are two inflection points, there will be three cases. The first case is x is less than -4. The second case is -4 is less than or equal to x is less than or equal to -2. And the last case is x is greater than -2. If x is greater than -2, modulus of x plus 4 is equal to x plus 4 and modulus of x plus 2 is equal to x plus 2. Therefore, the given equation becomes equal to x into x plus 4 plus 3 times x plus 2 plus 10 is equal to 0. This is x square plus 7x plus 16 is equal to 0. This is a quadratic equation. What is the discriminant of this quadratic equation? The discriminant is square of the coefficient of x, which is 7 square, minus 4 times 16. This is equal to 49 minus 64. This is less than 0. So this will have no real solutions. If you are looking at the second case, where x lies between -4 and -2, modulus of x plus 4 will be equal to x plus 4 and modulus of x plus 2 will be equal to -x minus 2. Therefore, the given quadratic equation becomes equal to x into x plus 4 minus 3 times x plus 2 plus 10 is equal to 0. This is x square plus 4x minus 3x minus 6 plus 10 is equal to 0. This is x square plus x plus 4 is equal to 0. This also is a quadratic equation. What is the discriminant of this quadratic equation? The discriminant is square of the coefficient of x, which is 1 square, minus 4 times the coefficient of x square into the constant term, which is 16. This is equal to minus 15, again less than 0. So this also will not have any real solutions. Let us look at the last case, where x is less than -4. Here modulus of x plus 4 is equal to -x minus 4 and modulus of x plus 2 is equal to -x minus 2. So the given quadratic equation becomes equal to minus x into x plus 4 minus 3 times x plus 2 plus 10 is equal to 0. This is minus x square minus 4x minus 3x minus 6 plus 10 is equal to 0. This is x square plus 7x minus 4 is equal to 0. There will be two roots for this. X is equal to minus 7 plus or minus square root of 7 square, which is 49 plus 16 divided by 2. That is, one root is minus 7 plus square root of 65 by 2. Another one is minus 7 minus square root of 65 by 2. Square root of 65 can be approximated to equal 8 point something, 8.1 maybe, or 8. So this will be equal to approximately 0.55 if you are approximating square root of 65 to 8.1. In the second case, it will be, I think, approximately 7 and 8.1, 15.1, approximately minus 7.55. In this case, we are looking only for values of x which is less than -4. So it can't be 0.55, it has to be minus 7.55. So across all the three cases, there is only one solution for x. So the answer for this question is option A, which is equal to 1. In this question, we are told that alpha and beta, where alpha is less than beta, are the roots of the equation -2 plus root 3 into modulus of root x minus 3 plus x minus 6 root 6 plus 9 minus 2 root 3 is equal to 0. X is greater than or equal to 0. Then what is the value of square root of beta by alpha plus square root of alpha into beta? If you are looking at the equation, we have -2 plus square root 3 into modulus of square root of x minus 3 plus x minus 6 square root of x plus 9 minus 2 root 3 is equal to 0. This is the equation that we have. If you're looking at the equation, first thing that we should note is that we are told that there are two roots. Now here we have x, we have modulus of square root of x minus 3 and square root of x. So I would want to square this so that I can eliminate the modulus. But how do I actually square it? Because if I'm taking this to the other side, I'm going to get so many terms which are additionally in addition to modulus of square root of x minus 3. Then if you look at the second thing, I would want to definitely square this so that the modulus is eliminated. And if I'm squaring this, what am I going to get? Square root of x minus 3. This will be, the square of it will be x minus 6 root x plus 9. This is the square of modulus of square root of x minus 3. And I will notice that x minus 6 times square root of x plus 9 is actually equal to modulus of square root of x minus 3 whole square. So if I assume that modulus of square root of x minus 3 is equal to a variable p, because this is modulus, I know that p is greater than or equal to 0. And this given equation will be minus 2 plus square root of 3 into p plus these three make up p square minus 2 root 3 is equal to 0. Now this is a quadratic equation. In terms of p, we should try to calculate its two roots. This can be expanded to form p square minus 2p minus, this is plus root 3p minus 2 root 3 is equal to 0. If we take p common in the first two terms, this is p into p minus 2 plus root 3 into p minus 2 is equal to 0. This is p plus root 3 into p minus 2 is equal to 0. So either p is equal to minus square root 3 or p is equal to 2. These are the two possibilities for p. If I am looking at p is modulus of square root of x minus 3. So p is greater than or equal to 0. As p is greater than or equal to 0, it cannot be minus square root of 3. P is therefore equal to 2. What is p? P is modulus of square root of x minus 3. This is equal to 2. So square root of x minus 3 is either equal to 2 or square root of x minus 3 is equal to minus 2. Therefore, square root of x is either equal to 5 or square root of x is equal to 1. So either x is equal to 25 or x is equal to 1. This will be beta, this will be alpha. So beta divided by alpha is 25. Beta into alpha is also equal to 25. And the square root of both of them will be 5 and 5. So the required answer is square root of beta by alpha is 5. Square root of beta into alpha is 5. This will equal 10, which is option B. In this question, we are told that there is a building construction work that can be completed by two masons, A and B together. And if both of them are working together, they take 22.5 days to complete it. A alone will take 24 days less than B to complete it. So if you assume that time taken by A is A days, time taken by B will be A plus 24 days, because B is taking 24 days more than A to finish the job. If both of them are working together, the job will be done in 22.5 days. So in one day, what fraction of the work is done by A? A finishes the whole task in A days. So in one day, he will do 1 by A part of the job. Similarly, in one day, how much fraction of the work is completed by B? B finishes the entire work in A plus 24 days. So in one day, B will finish 1 divided by A plus 24. Now if both of them are working together, the job is finished in 22.5 days. So if both of them are working together in one day, the amount of work that they will do, or the fraction of work that they will do, is 1 divided by 22.5. This is basically the equation that we have. If you simplify it, we are going to get a quadratic equation. Once we solve the quadratic equation, we can get the value of A. 1 by 22.5, if you are simplifying it, is 2 by 45. So you can simplify this. This is A plus 24 plus A divided by A into A plus 24 is equal to 2 by 45. This is 2A plus 24 divided by A into A plus 24 is equal to 2 by 45. We can divide both sides with 2. So you are going to get A plus 12 divided by A into A plus 24 is equal to 1 by 45. If you cross multiply, this will be 45A plus 45 into 12 is 540 is equal to A square plus 24A. Or the quadratic equation we have is A square minus 21A minus 540 is equal to 0. This is A square minus 36A plus 15A minus 540 is equal to 0. This is A minus 36 into A plus 15 is equal to 0. So the value of A is either 36 or A is equal to minus 15. The number of days in which somebody can finish a job cannot be negative. It has to be positive. So the number of days A takes to finish the job will be 36 days. So the correct answer for this question is option A. In this question, we are given a quadratic equation. This is the quadratic equation. 12x square minus 20x plus 3 lambda is equal to 0. And we are told that alpha and beta are the two roots of this quadratic equation. Now we are also told that 1 by 2 is less than or equal to beta minus alpha, which is less than or equal to 3 by 2. Then the sum of all the possible values of lambda is what is asked. If you are given a quadratic equation which is of the form ax square plus bx plus c is equal to 0, this quadratic equation will have two roots. What is the sum of the two roots? Sum of roots is equal to minus b by a. And what is the product of roots? The product of roots is equal to c by a. In this question, the quadratic equation that is given to us is 12x square minus 20x plus 3 lambda is equal to 0. And the two roots are told to be alpha and beta. So what is the value of alpha plus beta? Alpha plus beta is 20 by 12, which is equal to 5 by 3. What is the value of alpha into beta? Alpha into beta is 3 lambda divided by 12, which is equal to lambda by 4. So we know the sum of the roots, we know the product of the roots. In addition to it, we are given some information about alpha and beta. We are told that 1 by 2 is less than or equal to modulus of beta minus alpha less than or equal to 3 by 2. In quadratic equations, whenever you are given the difference between the roots, one good way to use it is by squaring it. Why is that the case? Because beta minus alpha is not something that you can easily get from a quadratic equation. But we know that beta minus alpha whole square is equal to beta square plus alpha square minus 2 alpha beta. This is beta square plus alpha square plus 2 alpha beta minus 4 alpha beta. Or this is simply equal to beta plus alpha whole square minus 4 alpha beta. So whenever you are given beta minus alpha or whenever you are given difference between roots, try to square it so that you can express it as the sum of the roots whole square minus 4 times the product of the roots. In this particular question, 1 by 2 is less than or equal to modulus of beta minus alpha is less than or equal to 3 by 2. If you are squaring this inequality, you are going to get 1 by 4 is less than or equal to beta minus alpha whole square is less than or equal to 9 by 4. But like we just discussed, what is beta minus alpha whole square? It is beta plus alpha whole square minus 4 alpha beta. Beta plus alpha is 5 by 3. 4 beta alpha is lambda by 4 into 4. So beta plus alpha whole square is 25 by 9 minus 4 times alpha beta is minus lambda. So basically this is 1 by 4 is less than or equal to 25 by 9 minus lambda is less than or equal to 9 by 4. This is the inequality that is given to us. From all parts of the inequality, let us just subtract this term, which is 25 by 9. What is 1 by 4 minus 25 by 9? This will be equal to minus 91 by 36. So minus 91 by 36 is less than or equal to minus lambda is less than or equal to what is 9 by 4 minus 25 by 9? This is minus 19 by 36. Now 91 by 36, 90 by 36 is 2.5. So this will be approximately minus 2.53 or so. Less than or equal to minus lambda is less than or equal to, this is minus 0. Approximately 52 or so, 53. Because 18 by 36 is 0.5. 19 by 36 approximately will be 0.53. So minus lambda is between minus 2.53 and minus 0.53, or the values that lambda can take are 1 and 2, because lambda has to be an integer. So the sum of all the possible values of lambda is equal to option B, which is 3. We are required to calculate the sum of all roots of the equation x minus 1 whole square minus 5 times modulus of x minus 1 plus 6 is equal to 0. To solve this question, let us assume that modulus of x minus 1 is equal to a new variable called p. Because we are seeing x minus 1 whole square and modulus of x minus 1. So if you assume that modulus of x minus 1 is equal to p, it becomes easier. So p has to be greater than or equal to 0. This is the first thing. And interestingly, x minus 1 whole square is equal to modulus of x minus 1 whole square, which is equal to p square. Because x minus 1 whole square is always greater than or equal to 0, it will actually equal modulus of x minus 1 whole square. So the given quadratic equation becomes equal to p square minus 5p plus 6 is equal to 0, and we want p to be greater than or equal to 0. So this would imply that this can be simplified to equal p minus 2 into p minus 3 is equal to 0. So we have two cases, either p is equal to 2 or p is equal to 3. But what is p? P is simply equal to modulus of x minus 1. So modulus of x minus 1 is equal to 2, or modulus of x minus 1 is equal to 3. So x minus 1 is equal to 2, or x minus 1 is equal to minus 2, or x minus 1 is equal to 3, or x minus 1 is equal to minus 3. So the value of x is equal to 3, or x is equal to minus 1. Here x is equal to 4, or x is equal to minus 2. So the given equation has 4 roots. The roots are 3, minus 1, 4 and minus 2. The sum of these two is equal to 2. The sum of these two also is equal to 2. So the overall sum of all the roots will be equal to 4, which is option A. In this question, we are told that alpha and beta are the roots of the equation x square plus 2ax plus 3a plus 10 is equal to 0. This is a quadratic equation. Every quadratic equation which is of the form ax square plus bx plus c is equal to 0 has something called a discriminant. Let us call the discriminant D. The discriminant of a quadratic equation is b square minus 4ac. Now if b square minus 4ac is greater than 0, the quadratic equation will have two real roots. If b square minus 4ac is equal to 0, it will have one distinct real root. That is, it will have two real roots which are equal to each other. Whenever you are told that the roots are the same or something like that, it would mean that b square minus 4ac is equal to 0. If b square minus 4ac is less than 0, the quadratic equation will have 0 real roots. That is, both the roots will be complex. Here we are basically asked that we'll have two roots, alpha and beta. Alpha is less than 1 is less than beta, so both the roots are real. So we want b square minus 4ac to be greater than 0. What is b square minus 4ac? That will be 4a square minus 4 times 3a plus 10. This has to be greater than 0. You can divide this entire equality with 3 inequality. So this is a square minus 3a minus 10 is greater than 0. This is a square minus 5a plus 2a minus 10 is greater than 0. You can take, this is basically a minus 5 into a plus 2 is greater than 0. So a is either less than minus 2 or a is greater than 5. This is the condition that is needed for the quadratic equation to have two real roots. In addition to it, we have to look at the condition such that one of the root is less than 1 and one of the root is greater than 1. For that, if you are having a quadratic equation like this, if say it has two roots like this, we want one to fall between both the roots. This is alpha and this is beta. If you want one to fall between both of the roots, what is the condition that is needed? The condition that is needed is that at 1, this point has to be less than 0. That is, f of 1 has to be less than 0. What is f of 1? Instead of x, substitute the value of x to be equal to 1 over here. This will be 1 plus 2a plus 3a plus 10 has to be less than 0. That is, 5a plus 11 has to be less than 0, or a has to be less than minus 11 by 5. So we want a to be less than minus 11 by 5. This is needed. We want a to be either less than minus 2 or a to be greater than 5. If you are looking at it, the interval in which both the conditions are satisfied is when a belongs to minus infinity to minus 11 by 5. So the answer for this question will be option A.
మీ ఫోన్ ఆల్రెడీ జేఈ నుంచి చాలా డిస్ట్రాక్ట్ చేస్తుంది. నౌ లెట్ ఇట్ టేక్ యూ ఫ్రమ్ స్క్రోల్ టు స్కోర్. 10 minutes ఫ్రీ ఉందా? మీ డైలీ టార్గెట్ ఓపెన్ చేసి కొన్ని క్వశ్చన్స్ సాల్వ్ చేయండి. ఒక క్వశ్చన్ దగ్గర స్టక్ అయ్యారా? IITN ఫ్యాకల్టీ వీడియో సొల్యూషన్స్ చూసి నేర్చుకోండి. చాప్టర్ కంప్లీట్ అయిందా? 12,000+ JEE PYQs నుంచి ప్రాక్టీస్ చేయండి. డౌన్లోడ్ ది క్రాకు JEE యాప్ నౌ. మీ స్క్రీన్ టైమ్ని ప్రెప్ టైమ్గా మార్చండి.